Yes, yes, Bridget.
Good morning, sir.
Good morning.
Okay, let's humble for the word of prayer when we're going to enter our lesson. Oh dear loving Father, we thank you for this morning. We thank you that you have done it for us, that we have made it till now, King of Kings. When we are going in this lesson, oh dear Father, that you enable our teacher to teach us so we can understand and grab everything that is going to teach, and let we all the students grab everything that the teacher is going to teach. In Jesus' name I've prayed.
Amen.
Amen.
Thank you so much for the word of prayer, Bridget. Like I promised, this week we shall always start on time, no waiting for anything. Now, today our topic, the theme we are going to deal with is data and probability. And specifically, today we are going to concentrate on an area of matrices. So today, where we are going to concentrate on matrices. Those who have been with us, we did set theory, we did data collection, display, and presentation. Maybe when time allows, we shall do some graphs and then probability. But when you are looking at set theory, you must as well look at probability. So that's what we are going to look at. Now I'm going to start with what are the do's and what are the don'ts. One is that when you are dealing with matrices, I want you always to first summarize your entries. What do you mean by entries? When you look at the data, when they give you the scenario, first have a simple table. Have a simple table and first summarize your data in a very good way. Take an example, they have given you data, first summarize. Let me say they have given you children. They have said that this is Bridget, this is Mike, maybe this is Joyce. And maybe they went to the shop, they bought maybe beans, they bought maybe cakes, they went on and bought maybe sodas and the rest. So first summarize, find out what did Bridget buy, that these were 3, 2, 1. 1, maybe 4, 2. 1, 5, maybe 2. So first summarize it in a simple table. Then here you are going to put for us the heading. You say a table summarizing. You say table summarizing the things bought by the 3 children. Now, after summarizing it, that is when you're going to go on and extract now your matrix. So you go on and extract, you say this is 3, 1, 1. In fact, when you are extracting, for you just extract it the way you have summarized it. You just put the entries, say 3, 1, 1, 2, 4, 5, and then 1, 2, 2. But after you have summarized. Why? Such that someone who's going to be marking you has to know that the first entry is for Bridget and it is representing beans. The second entry is for Bridget and is representing cakes. The third entry is for Bridget and is representing soda. But you don't just come out of the blue and for you just write your matrix without showing what do they represent. Hope that is okay. But as well, you can here put that this is Bridget, this is Mike, and this is Joyce. Then up here, you put that these are the beans, these are the cakes, and these are the soda. Let someone who's marking know what you have put inside your matrix. That's what I'm saying. First, summarize your matrix in a simple table, extract your matrix, and then show us what they represent. Number 2, data presentation is going to be very key. How are you presenting your data? When you are presenting your data, make sure that there is some logic flow and be deliberate on what you are doing. Say that this is my data. So make sure that there is that kind of flow and your data is well organized. Because when you're looking at matrix, we are looking at how are we arranging our data in a rectangular or in a square form. 3, I want you to always write the title. Take an example. They have told you to summarize your data. Put there a title. Say, a matrix. You can say or in case it is one, you say a matrix showing they may be, in case they are consumables, you say the matrix showing the consumables. Then you put your matrix. So here they are going to say, this child knows how to present data. Knows, because now you have put a heading to show what you are doing. Then clearly define what you're using. Don't just come out of the blue and say B, C, S. This is B, M, J. Without defining what does B stand for, that in case it is Bridget, show us that B stands for Bridget, M stands for Michael, J stands for Joyce, B stands for beans, C stands for cakes, and S stands for soda. Then number 4 is what you call the conclusion. When you find these matrix questions, they'll always want you to have a conclusion. They'll ask you, was the person fitting within the budget? That one can be your last question or parts after making your calculation. Then it means that you are going to look at the answers you have obtained and you make a decision. Say, yes, the person is fitting within the budget. What is the reason? Then you say, because the amount or the expenditure is less than the money that was budgeted for, and by how much? Because I told you we must look for that excellence mark, and that excellence mark will come with the way you are reasoning. So you put even the figure that by this figure, because you said that he is fitting into the budget because the expenditure or the amount of money spent was 100,000, yet he had budgeted maybe for 200,000. Therefore, he has been able to save about 100,000. So you must make a you make a decision that yes or no. Yes. Then after you say, you give the reason why you are saying so. Then what we have as units, where necessary. Take an example. These are beans, or these are cakes, and these are sodas. Maybe in case beans, and they told, and maybe Bridget was buying in kilograms, what, they may ask you at the end of the day, what was the total of each of the ingredients they bought? So now here, like beans, in case these were given in kilograms, then you are going to say 3 plus 1 plus 4. So you say that at the end of the in the total, you will say that the total, or the total kilograms of beans bought, or the total the total kilograms of beans bought were 4. Then, like in case you are writing, or you can say that the beans was equal to 4 kilograms. So where necessary, put the units that have been used. In case there are kilograms, you put kilograms. In case there are grams, you put what? Grams. In case you are dealing with money, do not forget now to put the shillings. Then clearly, show your working. Some of you always want to jump some few steps. Please clearly show your working. Don't jump out because I know at times you know what to do, and for you just jump out anyhow. Then number 3, stick to the strategy. When we look at the strategy, take an example. You look at the number. The number is matrix. Please use the matrix. In case they ask you for more, take an example for this. I know you can do it manually, but now always read and understand. So summarize your data. Make sure you stick to that strategy. In case you have noted that you can use matrix throughout. Do not change from one point to another, from this to this, from this to this. So please make sure you go on and stick to the strategy you have chosen. Then what are some of the don'ts? One of the don'ts I want you to pay attention is that do not jump steps. Sometimes that step you are jumping might be the step where they are going to award the score. Take an example. You may find that maybe you are adding 2 matrices, 3, 1, maybe 4, 2, and maybe you are adding it to another matrix, maybe 1, 3, 4, maybe 0. And for you, because you know you can add it, you say 3, 1, that is 4. 1, 3, that is 4. This is 8. This is 2. Now, here you have jumped out a step of adding, of showing how you have obtained what? The 4. So do not jump out to the steps, however much you know how to do it what? Directly. This step you are jumping, they will say, that step is very important, because they will say, here, when they are awarding, they are going to say, as he showed a good strategy, that yes. Is there a sign for matrix addition? That yes. Then they come here. Has this showed clearly how to add the two matrices? That no. How many marks are we giving? Here we shall give 4 for each addition seen. Now, are you seeing how you're going to miss out around 4 marks? Because you have not shown, but here on the answer, they will say, he has a good conclusion, he has the answer. They will give you the score. But because you have jumped out, you find yourself that you are jumping, you are missing out the marks. So first clearly show all your working. Do not jump the step, however much you know how to do it quickly. No, do not jump out. For you, show clearly each and every step. Act like that baby that goes through all the paths. Yeah, just act. And for you, because that step you might jump out might be the crucial step that they are going to award. Yes. So that one is very, very, very key. So do not forget when you're there. Even the conclusion, sometimes they ask you what was maybe the quantity for each. Clearly show and conclude that this one would have spent this one will spend this and this. So that one is very key when you are dealing with the matrix. You may look at the number and you think it is very easy, but because of the steps you keep on jumping, you may end up losing the marks. Those students who did, I think it was, I saw in about 4 mock bodies where they set numbers of matrix. No student scored above a 20. Reason being is that some of you kept on jumping steps. You kept on jumping what? Steps. And those steps were jumping were the crucial steps. Okay. Now, what are the must-know things as we are dealing with the matrices? One is what we call the addition of matrices. This one is very crucial. That is number one. You must know how to add matrices. Adding of what? Of matrices. That one is very crucial. And you have to know that when we are adding, we know that if I have two matrices, this is my matrix, let me call it, let me put here 1, this is 2, this is 3, this is 4. And I'm adding it onto another matrix, maybe 4, 5, 6, and 1. You should know that when you are adding matrices, we always add corresponding entries in the same position. This one can only be added to this. So, and we expect you to show it clear that this is 1 plus 4. Then this one can only be added to this. We expect to write 2 plus 5. This one can only be added to this. So we expect you to say 3 plus 6. Then here we expect you to say 4 plus 1. Then after, show that my end matrix will be 1 plus 4, which is 5. 2 plus 5, which is 7. 6 plus 3, that is what? 9. 4 plus 1 is 5. You show clearly how to add, even when there are 3 matrices, because you may find that you're working and they have given you very many things, 1, 3, 1, 4, 1, 2, plus, and you're adding it onto another matrix like that. Still add the corresponding components. Show clearly that this is 1 plus 1, 1 plus 1, 1 plus 1, 3 plus 0, 4 plus 0, and then 2 plus 1. Then continue and say this is 2, this is 2, this is 2, this is 3, this is 4, and this is 3. So you show clearly how you are adding those matrices. So don't jump out to this step of how you are adding. 2 is the subtraction. So we know very well that when we are subtracting 2 matrices, still we follow the order. You say 4, 3, maybe this is 4 and this is 5, and you are subtracting. Let me say this is your matrix. Still show clearly that I'm subtracting this entry and this. Don't just do it mentally in your head. So show 4 minus 1. This is 3 minus 2. This is 4 minus 1. And this is 5 minus 0. Then come up and say that now my answer here is going to be 3. It will be 1. It's going to be 3. It's going to be what? It's going to be 5. So show clearly how you are subtracting the matrices. Do not just come out of the blue, because here now they can give you a scenario and they say that this person had planned for this and this, but later on he realized that he needed to reduce on the items maybe by 2 on each of the items. So we expect you now for such a case, if your strategy is using matrices, we expect you now you are going to show the first quantities that were being bought. And then the other scenario, when the quantities were reduced, maybe they can tell you that on reaching the shop, he noticed that the money he had couldn't buy the items he had budgeted for, and therefore he made a decision to reduce on each of the items by 2. Or yes, to reduce on each of the items by 2, meaning that there now, you need to know that when they are reducing on the items, they are applying matrices. So you need to know what it is. Okay, so that is very important when it comes to subtraction. Subtract the entry and the corresponding entry. Entry and entry. Entry and entry. Entry and entry. So you look at the positionings of those entries. Now, number 3 is what we call the multiplication of matrices. And this one expect when it comes to multiplication. Now, where do we usually make the mistake? The mistakes we usually make them when it comes to multiplying of matrices. So when it comes to multiplication, the order will matter a lot, what we call order of the matrices. So when we are multiplying, let me say you are multiplying matrices, you need to know that if I have a matrix 3, 1, 4, 2, and I'm multiplying this matrix times maybe 4, 1, 0, and 2, the order of the matrix will matter a lot. What is the order? When you look at this matrix is by a 2 by 2. And we know that when they talk about order, they talk about the number of rows and the number of columns. So for this partition matrix, it has 1, 2. So the rows are 2. And then the columns 1 and 2. So you look at the matrix you are going to multiply it with. When you look at this matrix here, you notice that its order is what? It is also an order of 2 by 2. Now, the moment you find that the number of rows in the first matrix is equal to the number of columns in the second matrix, then it means that those two matrices can be multiplied. So if you find that you look at the first element here, this is a 2, and you look at the columns for the second are 2. The moment you find that these two are the same, then it means that you can be in position to multiply those matrices. So the order will always matter a lot. So the number of columns and the number of rows must always be able to match. So that one is really very, very important. So when you look at this, it should always match. Take an example. Yes, take an example. If you find that you have this matrix, this is 4, 1, and 2, and maybe they have given you money, 500, 200, and 300. You first ask yourself, can these two matrices be multiplied? For you, what are you going to do? You are going to ask yourself, what is the order of this matrix? That this matrix, it has 1 row, and how many columns? 1, 2, 3. These are the columns, 2, 3. So this is 1 by 3. Ask yourself, this matrix you are multiplying, how many rows does it have? So it has 1, 2, 3. So it has 3 rows. Then how many columns? It has 1 column. Then ask yourself, can I be in position to multiply this matrix? Then if you are in position to multiply, then ask yourself, here, what are you going to look at? I want you always to observe this. The moment you find that those two things are the same, then just jump and say those two matrices can be multiplied. So if the number of columns, remember these are rows and these are columns. These are rows and these are what? Are columns. So the moment you find that the number of columns in your first matrix is equal to the number of rows in the second matrix, then it means that you can multiply those two matrices. So the condition when it comes to the multiplication, it means that the number of columns in the first matrix, must be always equal to the number of rows in the second matrix. So for you to find out whether you can multiply, always look at that. The moment you write your order, look at those two things. Then to know the resulting matrix or the matrix that is going to come after, I want you always to look at what is remaining, the rows and the columns. So that is what determines. So take an example. When I give you 3 by 2, a matrix and you have another one whereby it is 3 by 2. When you look at these two matrices, you cannot multiply them because these ones are not the same. So here, you cannot multiply. The moment you read your matrix and you find that this is the order, it means that you cannot multiply them. If you find a matrix 4 by 4, and I'm multiplying this matrix by a 4 by 3, the moment you notice that these two are the same here, it means you can multiply those two matrices. And the result that you are going to get is going to be this and what is remaining. So you say my order will be 4 by 3. Hope that is very important. I always want you that as you are writing your matrix, take an example, you have summarized your data and you have got something like this. You have finished to summarize your things and now you write something like this. You write, let me say this is 400, this is 500. Ask yourself, what is the order of this matrix? That this is 1, 2, 3. This is 1, 2. So meaning that this one is the number of rows are 3, but the number of columns are 2. What about this one? It has the number of rows is 1. Number of columns, 1, 2, 3. Then, if you find such a matrix, the moment you notice that these ones are not the same, you cannot multiply that what? That matrix. Meaning that you're going to ask yourself, what is that mistake I've made? It means that now you need to change the order that you have written such that these two numbers match. Yes, some of your times you forge around, You forge around and you just multiply things anyhow. But I want you always pay attention to the order of that matrix because it's going to help you when you are multiplying. Don't forget that now in here when we are marking, what is very important, we are going to look at how have you written your matrix. Yes, some of you, you may have the right answer, but when it is coming from a longer approach. Take an example. You may summarize your data very well. You may summarize your data. Maybe you have finished to summarize something like this. And then you come for you when you are multiplying and you put your matrices like this. So please, when you put it like this one is going to be wrong. Ask yourself, what is the order? This is 3 by 3. What is the order for this matrix? This matrix is a 1 by 3. But since these ones are not the same, meaning you cannot multiply these what? These matrix. So much as even you can forge around and you multiply your things and you get the answer. Because there is no coherence in your work, it means that you have not done it right. So we expect that now, if it is for such, I can expect you to have 3, 3, 3, 4, 1, 5, 6, 3, 4. This as your matrix. Then you ask yourself, in case it is this, 500, 300. Then ask what is the order? This is 3 by 3. What is the order for this matrix? This matrix is 3 by 1. The moment you notice that these ones are the same for the matrices that you are multiplying, then you go on and multiply. But if you find that they are not the same, then kindly do not multiply. Another person, take an example. Someone comes and writes like this, 300, 400, 500. Then he comes here and writes 4922. Then you ask yourself, first ask yourself, can those two matrices be multiplied? You ask, what is the order of this matrix? That this matrix has one row, this is the row, and how many columns? 1, 2, 3. So the columns are 3. Then what about this matrix? This matrix is a 2 by 2. Ask yourself, are these the same? That no. So meaning that you cannot multiply them. So the moment you find that these ones are not the same, then it means you cannot multiply them. So it is really very important. Do not just multiply. Yes. So you cannot multiply them. Okay. So it should be the second number in the first set and the first number in the second. Okay. Okay. Yes. Now, if at all you find out that they are not the same, then you interchange. Then that one shows you that you interchange. The moment you find that they are not the same, then kindly go on and interchange them. So you just go on, interchange the matrix until you see that yes, Faizo, what you are saying now, it is okay. So you interchange the matrix and then you'll be able to come with that. Okay. Okay. Yes, even if it is money, even if it is money, even if it is money, please always make sure you first check out whether those matrices are compatible, whether you can multiply them. Okay. Okay. Oh, okay. Now, let me see. Is there any question before we start? In case you have any question, I was going through the chat to check whether the order doesn't, when it is addition, the order does not matter. What matters is the position, is the position of your entries. Yes, Mike. Mike? Okay. John?
Good morning, teacher.
Yes, good morning.
Yes, teacher, what if I arrange my matrices
Mm.
and they are not compatible? Can't I interchange them
Yes,
and I
now
see
that
whether...
means the moment you find that you cannot, you interchange them and then
Mm.
you continue with the multiplication.
But still, if they refuse, that means there is an error.
No, they can't refuse as long as for you, you read, the moment you
Mm.
read, the moment you find their order and you find that these two numbers are the same, it means you can multiply them. So for you, you have to just check out how can I write them such that these two numbers are the same.
Oh,
Mm.
thank you, teacher.
Okay. Okay. Mike?
Good morning, teacher.
Yes.
Yeah, like in the part of subtraction, you are like the guy went to the market and he decided to reduce the items by two. So are we supposed to multiply that two by each item or something else?
No, like you reduce on the items. Take an example. They may tell you that initially, this is what the guy are going to buy, something like this. And after realizing the money is not enough, it means that you are going to be reducing on each item by two.
Mm.
So now that means you are going to draw a matrix which has only twos, and then you subtract them.
Okay.
Is it fine? Okay.
Okay, clear.
Okay. John? Oh, John, I'm not getting it, John. Okay. I think we are failing to get John. Then someone was asking, under what circumstances under what circumstances do we change the order? Now, the moment you find that these two here for you, what is important before you anything with multiplication, before you go on, for you check out for you, I want always first check out whether you can multiply those two matrices. For you, just act mathematically. Ask yourself, can I multiply? The moment you find that these two numbers are the same, then go on. You say, "Ah, that one I can multiply." The moment you find that are not the same, then you go on and do the needful. You interchange them. The moment you find out that these ones are not the same. So that is when you go on and then interchange them. Uh, Now, someone is asking, what if we have one, one, what if we have this matrix, someone is having 1 and 3 and 2 and 2. So you notice that here you cannot what? You cannot multiply them. Then you ask yourself, now if you find that there is nothing at all that you can do to interchange, it means that now you need to go back and look at how you have summarized your data. Yes, that one is an indicator that there is something you need to change in your data, how you summarized it, such that you can, because here, even if you interchange, you cannot multiply them. So there's no way you can multiply this. So now if the number is like that, then that's when you can go in for the manual way. Okay. Teacher, I thought it's considered. Tricks. Take the question paper and then also do you do what if it is a question paper and they are not so do you no now please for when it comes to UNEB please expect everything always to be fine yeah, because those papers go through a lot Okay. Okay. Oh, yes. When it comes to, okay. Yes. Okay. Now we can start. We can start. Now, when you look at my screen, you are noticing that I have a question. Can you first read through? Can you first read through? Read through. And we are going to start how we can do it. Yes, so when they talk about compatibility of matrices, I saw a comment in the chat. Compatibility means that the number of columns in the first is equal to the number of rows in the second. So the person, I think it was Opio. Was it Opio? Was it Opio? I don't remember. I saw a comment. Opio, sorry, Ochopo Emmanuel. Compatible, your statement is the other way around. It means that the number of columns in the first is equal to the number of rows in the second. That's what you call compatibility. It means that you can multiply them. Yeah. But if you say rows is equal to that, that means you cannot multiply them. So Emma, you check out that compatibility means that can those two matrices be multiplied? So the condition for them to be multiplied, it means that the number of columns in the first should equal to the number of rows in the second. Let me hope, Emma, you have got that. Yeah, that's what we mean by compatibility. Compatibility means, are you able to multiply them? So the condition for you to multiply them is what I was showing you, that whenever you have two matrices, whenever you have those two matrices, you have you have those two matrices. The condition for you to be able to multiply, this is the first matrix and this is the second matrix, the number of columns here and the rows here, these two must always be equal. Yeah, so that is the condition. So for you, what you are saying, the rows here and the columns here shouldn't be equal. So there you cannot multiply them. So this is the only condition. That's what you call compatibility. Yeah. Hope you have got the difference. Yes. So compatible in simple terms means those matrices can be multiplied. Yeah. In simple language. Okay. Now we are going to start. Now the first thing we have said is we are going to first summarize our data. So I'm going to write, I'm going to just write here and say a table summarizing the items bought by the girls from the shop. Why am I telling you to do this? One is that we are looking for that thing that is going to make you an extra person. Putting into mind your time. So I'm going to come here as I'm summarizing. Now I will ask myself, what are the items that these people bought? One of them, you can notice that they were buying bread. So I'll say here, bread. Which other item were they buying? These people went on and bought bread. They had cakes, and they went on and also bought biscuits. And which people were these ones? Then I'll come here. We add Anne. Another person we had here was Betty. Then another one we had was Caroline. Now you start reading statement by statement. Some of your times you rush and you by the time you finish, you notice that you have made a mistake somewhere. So you start Anne bought 2 loaves. Then you come where there is Anne, you put those 2 loaves that Anne bought. So here I'll put 2. Then you go 3 cakes. Under Anne, I'll put 3 cakes. Then biscuits, there were 6. After that, I go to another person, Betty. Bought 3 here. 4 cakes. Under cakes, I put 4. Then biscuits, I put 5. Then I go coloring, bought 3 loaves. Then I'll go here, loaves. Cakes were 6. I put here 6. And biscuits were 3. I put 3. At times, even in statements to confuse, at times even they can interchange. Because some of you cram, or you may come and just do the things anyhow without looking through. So after doing so, now they want us to represent this info. Now you have summarized your data very well in the table. So someone marking will know that these ones are, this is bread, these are cakes, and this is the biscuits. So extracting them, it's just a matter of you just coming and say, now my summary of the data is going to be 2, 3, 3, 3, 4, 6, 6, 5, 3. And then you can't say that is my matrix. So you can say that is my matrix that I have summarized. So in case maybe you don't have that table, then for you now you need to come and write something. You say, this is Anne, this is Beth, and this is maybe who? Caroline. Then up here you will say this is bread, this is what? Cakes, and these are biscuits. So now that was how they wanted us to represent the information. Hope that one is very okay to everyone. Hope that one is very okay. We can now continue. Now, we continue today. Yes. Now, we have put the title is there. Yes, Jackie, the title is here. We have said that the table summarizing. Here you can even put, yes, you can say the summary showing here. In fact, now here for the matrix, our small title is going to be here under the matrix. You can say a matrix showing the items bought by the 3 girls. The items bought by the girls. Yeah. We look for the excellence mark in whatever thing you are doing. Yes. Thank you, Jack. Okay. Now we go to the next one. Now, next part, they told us that 1 loaf costs this. Then I want you to summarize, because some of you don't want to summarize. You end up interchanging other things. Yes, Maslin, having the title is what is going to make you an extra child from the ordinary ones. So I will come here and I summarize and I say, this is loaf of bread, and how much is it? It is costing this. Now, then I go to the next one. The cake is costing 500. Then I go to the biscuits. The biscuits, how much are they? They are costing 2,000. Now they're asking us use the matrix multiplication to find out how much. Then I'm going to the total amount of money spent by the 3 girls. So I'll come here and I say that the total amount spent by the girls, total amount spent. Now the total amount spent, you ask yourself, what are those matrices that I extracted? Now here I want you to be very, very careful. You'll come and you first write your matrix. 2, 3, 3, 3, 4, 6. I have 6, 5, and 3. Then you ask yourself, to get the total amount spent, it means that I'm going to have the ingredients or the items they bought times how much each of the item was. So now what are you going to do? You're going to ask yourself, how am I going to multiply them? Now, this is my order. So I'll come and I say, this is 500, and this is 2,000. Now, before I multiply, remember here, even you can put the total amount of money spent will equal to items multiply times amount for each item. Amount for each item. Then as you do that, first check out what is the order of the matrix. That this order is a 3 by 3. You have 1, 2, 3, 1, 2, 3. I hope people can see that. When you check out, this is 1, 2, 3. This is 1, 2, 3. So that's why you write 3. Then when it comes here, this is 1 row, 2nd row, 3rd row. So that will be 3 by, here it has only 1. And we have said the moment you find that these ones are the same, then it means that you can multiply those two matrices. So these two matrices can be multiplied. And now, what if someone goes on and writes like this? 6, 5, 3. And he goes on and he writes like this. 3 this, 500, and 2000. You ask yourself, what is the order of this matrix? This matrix is a 3 by 1. What is the order of this matrix here? It is a 3 by 3. But when you check, you notice that these numbers are not the same, meaning that these matrices can't be multiplied. So for you, the moment you write it like this, you are going to miss out on the coherence, on the flow of your work. Yes, because I know some of you at times forge life around and you come up with the right answer. But these two matrices can't be multiplied. Someone will just come and say, this one can't be what? Multiplied. So always check out that these ones are the same. Then at the end of the day, make sure that you look at this and this, what remained. What remained was a 3 by 1, meaning that your final answer is going to be a 3 by 1. Hope that one is very, very okay. Yes. So that one is very, very okay. Number 2, I want you now to start always reasoning out. Yes, I don't want you to just write things from nowhere. I want you also now to put in the reasoning part. When you look at our table, very well, this was representing loaves. This was representing cakes, I think. This was representing biscuits. When you look at the money, this one is representing the loaf, this one is representing the cake, and this one is representing by the biscuits. So I want you always to know that in case you have your loaf, you wrote your things in this order for each item, then your matrix, you'll multiply it like this. So because these are loaves, these are cakes, and these are biscuits. These are loaves, these are cakes, and these are what? Are biscuits. So mean that loaves are going to go with the loaves. Cakes will go with cakes. Biscuits will go with the biscuits. So in case you write your items like this, then it means that in case you have written your items in a low format, then it means that your money, you are going to write it in a column format. So that one, you reason out. You ask yourself, what is it? Is the thing I'm multiplying matching with other item? That yes, a loaf and a loaf. A cake goes with the price of a cake. The biscuit goes with the price of the biscuits. So that one is going to be very, very important. That's where now you bring in that critical part of it, of life, of thinking, not for you just to come out from nowhere and then you write something that is not working out. So now we are going to multiply. So we know very well that when we are multiplying the two matrices, I'll come here, allow me to come and I start from here. This is 2, 3, 3, 3, 4, 6, 6, 5, 3, and I'm multiplying it by 3, 5, 0, 0, 500, and I'm multiplying it by 2000. Now, what is going to happen? Now, what is going to happen? Like we know that we always multiply a row by a column. So I'm going to come and I multiply my matrices. Show how you are multiplying. Say this is going to be 2 times 3,500 plus 3 times 500 plus 6 times 2,000. Hope people are seeing, because I want you to take note that when I'm multiplying, this element here is going to multiply with this. Then this element, the 3, multiplies with this. Then this element 6 multiplies like that, because this is the row and then the other one is the column. So that's how I am supposed to multiply. Then I go to the second row. Now, when I go to the second one, I'm going to say to do 3 times 3, 5 plus 4 times the 500 plus 5 times the 500. I go to the next one, 3 times 3, 5 plus 6 times 500 plus 3 times the 2,000. Show clearly you're working. Do not jump. Do not jump anything. Yes. Teacher, can a matrix of amount come first, then followed by the matrix of the items? Yeah, given that you have arranged them very well. Okay, okay. So I don't know, someone is saying it is 2,000, not 5. Oh, okay. I don't know. Yes, someone who is saying that I've not yet understood. Marceline, I'm not saying what you are saying. Marceline, if you can, what is Marceline? Marceline, there's something you are saying in the chat. Yes, Marceline?
I'm saying that part of 5 times 500.
Which one?
They are 3 times 3, 500 plus 4 times 500 plus 5 times 2000, not 500.
Not 500?
Yes, on that column of 2000.
2000. Let me see. This times this. Oh, oh, here. Okay, okay. I've seen here. Okay. Yeah. Thank you. Thank you. So this was 2000. Hmm. Okay, thank you, Marceline. Yes, now when you check, you'll notice that the whole of this row, if you check very well, when you are making your multiplication, I want you to check, always you'll find that here, the money is the same. Here, the money is the same. Here, the money is the same. So the moment you find that that is the thing, the way you have the thing, then it means you are good to continue. Now we are going to continue with our work. Now, still, I've told you, do not jump the steps. Now go on to the next step of multiplying. Place your calc. For you don't just add things from nowhere because those steps you are jumping, those are the most important things. So you say, when I multiply, that is 7,000 plus 3 times 500, that is 1,500 plus 6 times 2, that is 12,000. So for you multiply, then 3 times that one, that is 10500. Plus 4 times 5, that is around 20,000. 2,000. Plus 5 times 2, that is what? 10,000. Then you go to the next one. That is 105 plus 6 times 5, that is what? 3,000. Then plus 3 times 2, that is 60,000. Now, after that, clearly, now add your things and put the total. That this is going to be 2050. Then the next one is going to be, that is the 225. That is what I'm getting. Then the next one is going to be 19500. Yes. Now, and do not forget that for matrices, you must put the what? The brackets. So put brackets. But when you look at the question, yes. So when you look at the question, yes, when you look at the question, you are going to notice that what does the question want? They told you that obtain the money spent by each girl. Now that was the first question. So I'm going to first come and I say the money spent, I will first make that conclusion. Now I'll say the money spent by, now our first girl was who? Our first girl was Anne. I said the money spent by Anne is, they use shillings. I will say is shillings 2050. The money spent by the next girl was, I think was who? Betty, is 22500. The money spent by is 19500. I conclude. Then from the conclusion, remember this was Betty and this is Caroline. Now, after concluding, that's when now I'm going to go on and go to the hence part because there was a full stop. Then I told you that hence determine the total amount of money spent by the 3 girls. So now I'm going to come here and I say total amount of money spent. Total amount spent by the 3 girls. Then you know that if I'm getting the total, I'm going to add. So then you come, you add, I don't know, this is 22500, then you add. Then after adding, you say that this is shillings, that is 00. You put those 2 zeros, that is 5, that is what, 2, and this is what, 6. Yeah, something like that. So that is now the total I'm getting for all the 3 girls. Total, Muffin, can you check out Muffin, how you're getting that? Is my answer correct when you add? Maybe members can add. Yes, members, Don't we put the last part in a matrix form? Now, like Shadrach, we are adding, we are adding. We are adding. Yes, okay, people, yes, okay. Okay, yeah, that is okay. That is how we do that particular number. Then you are going to conclude and say that the total amount of money spent is or was shillings 62500. Okay, I'm seeing a hand. Mike and Burana.
Good morning, teacher.
Yes, good morning.
Teacher, can't I do like for each individual, I do it alone, then I add at the end of it?
Now that one is going to take you a lot of time. And remember, the reason why we do matrix is for us to have our data summarized. So if you do one individual, it is okay. Your work will be correct. But mind about the time that you are going to spend working on each and every item. But it is very fine.
But
It
teacher,
is very
it reduces the risk of you making a mistake.
Yeah, that is true. It reduces the risks involved in making the what? The mistakes. Yes. But since they want yes, it is very okay. It is very okay. But though I would advise that if you know how to multiply very well, that one you can just use it as a checker at the end of the day, whether what you have done is right. Yes. And remember, for these numbers of matrices, even you can check your answers using the manual way. The manual way, like for you trying it manually without using the matrices, such that you prove your answer. Yes, Brana?
Yeah. Yeah, like me, my concern is that this part of like summarizing the table, like you are like, we can even put it can we put it even in form of matrix form, as long as we put that the heading and the items plus those who bought them?
Yeah, as long as you put there that the matrix, in case you have written the matrix, you said the matrix showing this and this.
Even if I don't draw the table,
Yeah.
it's okay, right?
But I've said the good thing with a table, it helps you to summarize your data very well. At times they jump out some things, and for you, because you are panicking, you may not be able to see it.
Okay.
Yes. Sadwick, yes. So let me hope the gentleman who was asking for one by one, what you meant that when you are doing one by one, still you are using matrix multiplication, that you are going to
Yes,
summarize your data like this, and then you multiply.
yes, teacher, it's what I meant.
Something like this. Yeah. Then you show your own matrix. Though I'll advise you to use this approach more. Then that one, you can just use it for proving. Okay. Now that was our first item. Then we go to the second item. First read through the second item. First read through the second item. What if I put both aspects in one conclusion? Baleke, that one is like putting all your eggs in one basket. What if the basket falls at once? Everything, you may lose everything. So better you conclude in parts, such that in case the other one is, maybe there is an error, you can at least be able to get the other one. Chalewa Justice, I've not yet seen your concern. Yes, we are reading through the question. Or highlight more about the matrix multiplication. Okay, Justice, I think we shall use this number we are going to do. I will highlight more about it when it comes to matrix multiplication. But what you need to know is that when it comes to matrix multiplication, as people are reading, whenever I have a matrix and I'm multiplying it, maybe something like this. Whenever I am multiplying, this is a row and this is a column. So this row here will always go with this column here. So I'll multiply 3 times 3 plus 4 times 2. Then the same row will go with the second column here. So I will multiply 3 times 4 plus 4 times 4. Then this, again, this one will go with the third one. So for you must make sure that you are multiplying a row and by a column. And that for each element, in case you have 3 elements in the row, let them be able to multiply also 3 elements in the column. That's what we are saying. So those ones must be always equal. Okay, now we are going to start. Now, like I've already advised that for me, I always love to first have my work summarized. But when you look at this particular question, they're telling us that in a certain village, the age of a man was 4 times as old as his daughter during the census. Each 8 years ago, the product of their ages was 160. A catering service organization was given. Now, this one is one of the questions I picked from one of the mock papers. I don't actually remember which mock paper, but I know it is a mock number. Now, the first thing always you do now, because they want you to help the census people determine the ages of the man and his daughter. Now, what are you going to do? I want you to summarize. Me, I always love the summarizing. But as I am going to summarize, I'm going to first draw my simple table. Now, in the simple table, I'm going to have, since we have 2 people, we have the man and you have the daughter, like father and then the daughter. This is our daughter. Now, I will come to the table here and then I'll have a table of this nature. Then I'm going to say, since we don't know their ages, I'm going to say, since they're telling you that the age of a man was 4 times as old as his daughter. So I'm going to say that let, in fact, even before I can say let the daughter's age, let the daughter's current age be maybe X. Now, in my table here, I'm going to put current age. Then I also put past age. We call it what? Current age and the past, current age and the one for 8 years ago. Now, if the daughter is currently X, the father, they have told that is going to be 4 times as old as his daughter. In the chart, what will be the father's age? Can we type quickly? I want to see. In the chart, what is going to be the father's age? Very good. So the father's age is going to be 4x. Now, they have told us that 8 years ago, 8 years ago. Now here I'm going to say 8 years ago. Now, ago means past. In simple terms, past. Past 8, the past of 8 years. Now, I want in the chart, 8 years ago, take an example. If now I'm currently maybe 29 years. 8 years ago, what was my age? Quickly in the chat. If I'm now, people even have already put the answer. 21, very good. So meaning that now the way you have got 21 is you have subtracted. So meaning that for our man, we shall say it's going to be 4x minus 8. Then for the daughter, it's going to be x minus 8. Now, after you summarizing your table, then continue. They are telling you that the product of their ages was 160 years, meaning that in 8 years ago, their age was 160. Now, this is the 8 years, meaning that when I multiply the age of the daughter and the man, I must be able to get 160. So I'm going to come here and I say 4x minus 8. The moment I multiply it with x minus 8, I must be able to get the previous years. Now, when you look at this, you will notice that you have now gone into quadratic equations. Now, I'm going to open the brackets. And when I'm opening the brackets, do not forget, when I'm opening, I open well. Because after, don't jump steps, don't be. The whole of this 4x is going to multiply this. The whole of this one here is going to multiply this. So it is really very important. Don't jump. I know at times we are tempted. So I'm going to say 4x, I multiply it with x minus 8, minus 8 into x minus 8 should give us 160. Now I open. 4x multiplies the x. That is going to be 4x squared minus 4x times 8. For you, you show how you are getting it, but allow me now to to simplify it a bit. So this will be 32x. Now here is where people make a mistake. This is negative 8. That is where people now make mistakes when you have what? A negative. So this is negative 8 and you are multiplying it times x. This is negative 8 and you are multiplying it with negative 8. So do not make that error when you are multiplying. So what is going to happen? Here I'll have, so here I'm going to come and I will have minus 8x, because minus 8 times x is minus 8x. Then the next one is going to be minus 8 times minus 8. Negative times the negative gives you a positive. So here we shall have plus 64 is equal to 160. Now when I reach here, I'm going to simplify. So I'll have 4x squared minus 32 minus 8 is going to give you 8 plus 2, that is 10. So that is minus 40x plus 64 is equal to 160. Now you collect like terms. Never solve a quadratic equation when on your right-hand side, you don't have a 0. So you must remove that. So I'll come and I say 4x squared minus 4x plus 64 minus 160 is equal to, this side you'll have 160 minus 160. So here we shall have 4x squared minus 4x. Then 64 minus 160 gives you a negative. That is 96 is equal to 0. Now, after you doing that, you notice that this one is a quadratic equation. So you can first reduce it. By reducing it, you divide throughout by 4. So when I decide, I can say this one can be 4x squared minus 4x minus 9x is equal to 0. So when you divide throughout by 4, by 4, by 4, by 4. So here you end up with x squared minus, this is going to be, this is 40. I don't know why I was writing. This is 40. This is 40. So this is going to be, let me first erase and I write it well. Let me write this well. This was 40. So this is 40x. This was 40x. Then this is going to be 40x out of 4. Now here, we shall have 40x divided by 4. Here we shall end up with 10. So here I'll have 10x minus 96 divided by 4. That is what? 20. 24 is equal to 0. But confirm. 96 divided by 4, is it 24? Yes. Now, this is my quadratic equation. Now, after getting your quadratic equation, you are going to solve it to find the value of x. Now, when you are finding the value of x, it is up to you. Which approach did you use? Which approach do you know better? Is it a bulldozer? Is it any approach for you, you know better? Yes. Yeah. Yes. So any approach for you know better is what you are using, that you can use. So allow me now, people are saying we use bulldozer. I think that's what people want. Now allow me to create a new slide here for the bulldozer because it is a bit lengthy. Now, when it comes to a bulldozer, I've told you don't need to cram it. You just, what you do, you ask for those logbooks, hoping that they will provide them. So you'll come here and say my bulldozer. So our quadratic equation we have got is x squared minus 10x minus 24 is equal to 0. So our bulldozer is given by negative b plus minus root of b squared minus 4ac out of 2a. Now, when it comes here, extract, remember our standard equation, a quadratic equation is always given by that is equal to 0. Now, I want people to first extract for me. What is your A, B, and C from this equation? Place your answers in the chat and we see now. Place your answers in the chat. What is your A, B, and C? A is 1, A is 1, A is 1, A is 1. Yes, the bulldozer is in the formula. Okay. I'm seeing people are putting some answers here. People are putting some answers in the chat. Yeah. Okay. Yes, Captain Esther. I've seen Captain Esther. She's saying she has a question. Captain Esther, unmute.
Good morning, sir.
Morning.
I wanted to ask how 0 divided by 4 it remains 0. I'm
Oh,
confused.
you place on your calc. Do you have a calculator?
Yes,
Hey, so when you say 0 divided by 4, what do you get?
getting
Okay, now, Esther, you tell me. You have 4 friends who have visited you at home, eh? Now, these 4 friends have visited you, and they have told you, Esther, we want to take cake, but you don't have cake at home. What are you going to give them?
I have no cake at home.
But for them, they want to eat cake. So what do you give them?
Nothing.
So that is the meaning. That is the meaning.
Okay.
So that is what you call 0 divided by 4. That you
Okay,
have 4 people at home, but you have nothing to give them. So let them be there. Hey, you talk, let them feed on the jars. So that is the meaning. Okay. So 0 divided by 4 is 0. Yes. But 4 divided by 0, this one can't be. It can't. It can't be divided. That one, you'll get a math error. Okay. Now, looking through the chart, I've seen your answers. So I'm going to extract here. Here, there is an hidden 1. So I say A is equal to 1. Here, B is negative 10. So I say B is equal to negative 10. C is negative 24. So I say C is negative 24. So I'll come here and substitute. I say X is equal to negative. B is negative 10. I say negative 10 plus minus. Inside B is negative 10. So I say negative 10 squared minus 4 times A, which is 1, times C, which is negative 24. Everything out of 2 times 1, whereby A is equal to 1. So now I'll come, negative times the negative is a positive, so I'll get 10 plus minus. Now inside I have negative 10 squared. Now some of you place this on the calculator. And once you place it on the calculator is going to give you this. Please and please, negative 10 squared means negative 10 times negative 10. A negative times the negative is a positive. So your answer here is 100. Many of you, when you are rushing, this is what you place in the calc and you get a negative. You get something totally wrong. So always what you do, make sure that if you are to place anything with a negative in the calc, put a bracket first and then put a square. This is the function. This is how the calc was programmed, but it can't not solve for you that particular one. Yes, Chilabu. Chilabo, unmute.
Yes.
Yes, please. Okay.
I'm not
Okay,
very
I think.
familiar with that method.
Yes?
I'm not very familiar with that method.
Which method are you familiar with?
The one we use like common factors.
Okay, we shall also do that one.
Yeah, thank
Yeah,
you.
yes. Now you can be doing that method. It is very okay. So here I'll have 100, then you multiply. Here it's negative 4 times 1 times negative 24. So it will be 4 times 24, which will give you 96. So here we shall have plus 96. All of it out of 2. But now, Chilabo, you are risking because should a number come when those factors are points, at times it is a bit tough. So you may check out and at times fail even to look out for an easy factor. So please better learn all approaches. Better learn all approaches. It will be very good for you. So here we shall have that. So here I'll end up with the 10 plus minus. You ask what is the root of 196? Root of 196, that is what? 14 out of 2. X. Now here you say either I'll have 10 plus 14 out of 2, or I'll have 10 minus 14 out of 2. And please do not forget, this one divides everything you have up. So here we shall have This is x is equal to 10 plus 14. That is 24 out of 2, which will give us a 12. Then here I'll have 10 minus 14. That is what? 10 minus 14, that is negative 4 out of 2. And our answer here, we shall end up with negative 2. Then, since from this point that you are going to ask yourself, what is going to be my conclusion? Because we have x is equal to 12 and we have x is equal to negative 2. So what is our answer? What is the correct answer? What is the correct answer that we shall consider? X, you'll consider your answer as 12, yes, because age cannot be a negative. So here you'll conclude and say, therefore, the current age, because you said already that X represents the current age and X was representing the daughter. So you say that the daughter's age is 12 years. Then you will go on and then say, now what about the current age of the father? Yes, of the man. What is his current age? First, show the testing. Yes, Sunday you can put, the testing will work out. Yes, the testing will work out. It will work out. Yeah. So you just come here and you say this is 12 squared minus 10 times the 12 minus the 24. 12 squared, this is what? 144 minus 10, this is 120 minus 24. This will give you 114 minus 114, which is 0. So it will work out. Okay. Even when you put the negative 2. So the father is 40 years because the father, remember, he was 4x of the daughter. So you say 4 times 12, which will give you 40 years. So here you are going to conclude and say the man's age is 48 years and the daughter's age is 12 years. Even you can go on and check whether 8 years ago when you multiply, you will get that 100 what? 160. So 8 years ago, the father was 40. The girl was, that is the 12 minus 8. What do you get? That is what? 4. So 40 times 4 is 160. So it means that everything you have done is equal to correct. Okay. Yes. So currently the man is 48 years. 8 years ago, he was 40 years. And the daughter was a P4, was age 4. Okay. Hope now that is okay. We are going to continue to the second part. Okay, but before we continue now, those who are used to the other approach of factors, that is very okay. Use it. Jackie.
Okay, sir. For me, I did not understand where you removed that negative from B part. That x is equal to negative B plus O minus this one. Then you remove it somewhere here.
Where?
Where you have written 10 plus O minus. Then in the root is 100 plus 96. I did not understand how you remove that negative.
Which negative? This one here?
The one on, not that one. That one on 10.
On 10. On 10, I was saying
yes.
negative 10 squared is the same as negative 10 times negative 10. Negative times the negative is a positive. 10 times 10 is 100.
But sir,
I
think that one is the one I'm talking about is outside. It's outside this with not without square.
This
B
one?
outside. Yes, that one.
Yes, a negative and a negative yields a positive.
Okay.
A negative and a negative yields a positive. That's like multiplication. In simple terms, it's like having negative 1 times negative 10, which is still remains 10.
Okay.
Like here, if you notice well, here, negative B, there is always an hidden 1 here, which gives you negative 1 times B. So our B is the negative 10. So negative times the negative gives us a positive.
Okay. Thank you.
Okay. Okay. We continue now to the other question. Okay, now, after that, they told us part B, that in a certain village, okay, we have finished now. We are going to the second part. Now the second part is here. It's telling us that the organization, we are going to do now that second part of the organization, this part here. Now, when you look at the organization part, still we are going to first go on and do our summary. Like, I love using the table so much because it makes, when you look at, we have 3 serving tables. So I'm going to come here and I say, these are the tables. And you ask yourself, what do I have in the tables? That in the table, I have my table A, I have table B, and have table C. Then come, ask yourself, which items do you have? That I have Irish. On top, I have the matoke. I have the rice. I have the meat. Now, that is the order you are going to follow when you are summarizing your data. Now, when you are summarizing, please make sure you follow up well. At times they confuse the words, they interchange them, and because you are rushing, things do not come out the way you expect. 30 kilograms of Irish. So I come here and I put 30. Now, what am I going to do? Up here, I'm going to put kilograms. Here under matoke, I'll put kilograms. Rice, I will put kilograms. Meat, I'm going to put what? Kilograms. So I extract only 30. Then I got matoke, they are 15. Rice, it is 20. And meat, it is 10. Then I go to table B. I have 20. Now, when you look at table B, we have 20 kilograms of Irish. I put here 25. Matoke, we have 20. We have 18. And we have 12. Then I go to the last one. Irish, I have 35. Matoke, I have 25. Rice, I have 15. And meat, I have what? 9. Now, after that, it means that now I can be able to I've organized my data very well in a simple table. What did they tell you? As a member of the catering organization, help the management to organize the information and use it to determine the amount of money spent on the food stuffs. So here, remember, I'm going to put my heading, a table showing the serving points, and the items. Now, the next thing is that I'm going to extract my matrix. But when you look at it, you can also notice that still in your table, they told you that they want you to organize. So mean to organize the information and you determine. So in my table, I'm going to include as well. What am I going to include? I'm going to include the cost of the things. So now the cost, I can put it here down, the cost, and the cost I have Irish goes for 4,000. Then I have the matoke, which goes for, this is shillings, yeah? Or you can draw a separate table. Then here I have my rice, which goes for 5,000 per kilogram, and then meat, which goes for 18,000. Now this is my information. Then the next thing I do is that I'm going to extract the matrix. So I say matrix showing the items served on the 3 tables. So I extract my matrix. I say 30, 25, 35, 15, 20, 25, 20, 18, 15, 10, 12, and 9. So in other words, if you notice very well, you just extract the way the matrix is. In fact, you just remove the columns and then the rows. So you just remove, remove it the way it is, and you place it here. Then after that, remember here, they have told us to first organize. Now the next thing I'm going to go on and I organize now the cost. Now I'm going to say matrix. Sorry, I'm going to come here. Let me pick a pen. So I say matrix showing. Now here I'm going to organize for the cost. The costs of each item in kilograms. Now I write the cost matrix. So now the cost matrix, I'm going to come. I have told you already that in case you write all your items in row form, then your money has to be in the column form. So I'll start the first one. I started with Irish. Here it was 4,000. So I say this is 4,000. This is 2,000. This is 5,000. And then lastly, I'll have 18,000. Now I've finished to summarize my information. I have organized it very well in a way that I can be able to multiply it. Now go to the second part and use it to determine the total amount spent on the foodstuffs. Now ask yourself, the information you have organized, can you use it? Because you have to use what you have already summarized. So looking at our information, you can easily tell that now I can be able to use it in order for me to be able to summarize. Now I'm going to go to the second part. Allow me to create now a slide here again. I've finished to organize the information. Now I'm going to go on and multiply because now it comes from what you have organized for you to do the multiplication part of it. Okay, now under the multiplication, I'm going to come, allow me to get a pen. Then because now the question told you that organize the info and use to determine the total amount spent on the food stuff. Then I'm going to say total amount spent on the foodstuffs, spent on foodstuffs. So the total amount, it means I'm going to get my matrix. And my matrix I had was 30, 15, 20, 10, then 25, this was 20, this was 18, this was 12, 35, 25, 15, and 9. Then I'm going to be multiplying it times the 4,000, 2,000, 5,000, and then 18,000. Hope that is okay. Hope we are still on the same page. I've organized my matrix. I have summarized it in the table, and now I'm going to multiply. Kindly let me know, are we on the same page? Are we still together, or we are leaving some people behind? Okay. It seems people in the chat are saying we are together. Okay. Now, we are going to do the multiplication. Now, like we have said that when we are doing our multiplication, always we multiply row by column. So I'm going to first multiply this row. I multiply it with this column here. Is what I'm going to first do. So I'm going to come and I multiply that one. So when I'm multiplying, it means we are going to do, when I'm multiplying, I'm going to come here and I say, this is going to be, don't forget to put the brackets 30 times the 4,000 plus 15 times the 2,000 plus 20 times the 5,000 plus 10 times the 18,000. Then I go to the second one. I'll have 25 times the 4,000 plus 20 times the 2,000 plus 18 times the 5,000 plus 12 times the 18,000. I go to the next one. 35 times the 4,000 plus 25 times the 2,000 plus 15 times the 5,000 plus 9 times 18,000. That is now the multiplication. But I have already told you, always check out, always when it comes to money, you look here. Is it the same? Is here the same? Is here the same? Is here the same? Once you have that, then you say, aha, I'm on track. I'm on track now. Then we go to the next one. Multiply, I've told you, here, don't jump any step. Show all your working. Multiply your money very well. So here, 30 times 4, that is going to be 120,000. Plus, that is going to be, that is 30,000 plus 100,000 plus 180,000. You confirm 25 times 4, that is what? 100. So it's going to be 100,000 plus 20 times 2, that is 40,000 plus 18 times 5, that is what? 90. So it is going to be 90,000 plus 12 times 18, that is what, 216,000. Then I go to the next one, 35 times 4, that is what, 140,000 plus 25 times 2, that is what, 50,000 plus 15 times 5, that is what, 75,000 plus 9 times 6, that is what, 9, that is what, I think that was 18, sorry. This is 9 times 18, which is the 162. Yes, 162,000. Yes, members, first let me know whether my calculations are okay and we have the same. Kusulo Emmanuel.
Yes, sir. Good morning, sir.
Yes, good morning.
I have an inquiry. Is it okay? How do you determine whether to multiply post matrix first or it comes second in multiplication?
Yes.
Which standard that you're dealing with such numbers, post matrix comes in second?
Okay, you are not so clear. I'm not getting
post matrix. Multiplying. How does it? How do you determine whether the post matrix comes in second? So multiplying as you've done here. So this is a standard way of doing it.
No, it's not a standard. Another person can start with a cost and another one multiplies. But the only difference is that the matrix, like I've told you that when you are multiplying, look at the nature of the matrix you have. That is the first thing. Look at the nature of the item matrix you have. Now, after looking at the nature of the matrix, it is the one to guide you. Take an example. This one, you have formed 1, 2, 3. This is a 3 by 4. Now, ask yourself, which matrix am I going to multiply with it? It means that the matrix I must multiply with it must be a 4. If I'm to multiply, it means that this number must be the same times any other number, which is a 1. And this is what we always look out for, are they compatible? Is the number of columns in the second one equals to the number of rows in the first one?
Also, it's the number of rows and the number of columns.
The number of columns.
The number of rows and columns have to be the same.
Yes. Yes. But the number of columns in the first matrix must match the number of rows in the second matrix you are multiplying with.
Right. Thank you, sir.
Okay. Lukeire, people, let's get the total. Lukeire. Okay, sorry, Lukeire.
So, teacher, good morning.
Good morning.
I was asking on that thing of finding the nature of the matrix. If you're starting with the one that has like the kgs, you start row by column, and then the next one should be column by row.
I beg your pardon, where?
To get the nature of the matrix, to see if they are corresponding, yeah? To see if they are similar. When, let's say now for the kgs, you go 3 by 4. So for the price, you get the row by the column.
Yes. So here you have 1, 2, 3, 4. You have 4.
So you don't get, because when I was doing it, I was doing column by row, and I keep getting different.
Yeah. Now that is the mistake. You always do row by column.
Oh, okay. Thank you, teacher.
Okay. Okay. Let me look in the chat and I see which answers people are getting as I pick on Daniela and Elijah. People get the total. I want to see whether we have. Okay.
Okay, so teacher, the 120,000 is is it rice?
Which one?
There is matoke. The 120,000.
120,000. We don't have 120. Yeah. Hey. Oh, this first one, eh?
Yes.
Yes, it is for Irish.
Then the 30,000 is for matoke.
Yes.
So imagine they had asked us to find the amount of money spent specifically on matoke, then the amount of money spent on Irish differently. How would you get that?
Oh, now there you arrange your matrix differently. Maybe we are going to do it, eh?
Okay.
We are going to do it. We are going to try something of that nature. Yes. And in fact, there is a number. There is a number we shall do. But now that one, if they want specifically in that order, then it means that here it is the order. Here you will come, instead of your matrix, you arrange it like this. This is 2000 in this format here. Something like that. Whereby,
Because what
yes?
I did for that, when I reached the third step to find the total, I instead made it, you know, it's a 3 by 4. I made it a 4 by 3.
Oh, then you
matrix.
interchanged.
Yes.
Oh, now remember, your work must flow. There must be logic flow of your work. So what you had in the first steps must correspond with what you have.
Okay.
Are you getting it?
Yes.
Yes. So always first check out what the question wants. Because the question wanted us to find the total they spend. Not on individual. Now for you, what you were doing, it was going to lead you to what they spend on an individual item.
Yes, that's what I also did. And it starts bringing me to each of them, like Matoke, Irish, Matoke, each of them rice.
Now that one, you just interchange your matrix. You just now, like here for this particular one, instead of having 30, 15, 20, 10, put them like this. Oh, you're going to put them in this format like this, but also here you will change the matrix because you'll not be able to multiply.
Okay. Thank you.
Okay. Okay. Now, according to, I don't know, Elijah, unmute. Okay, Elijah, I think. Located, do you have a question?
Yes, teacher.
Yes.
So you said like we put the title. Here is the title, total amount spent on foodstuffs.
Yes. No, like here, this is not the title. Like the title, I emphasized it here, like a matrix showing this when you are summarizing your data. Okay, hope you have seen how I've summarized my data. Yeah. So here you just equate, you say that what, like you show what are you doing? Clearly define. That's what I call defining. That clearly show what are you defining. Yes, Jemima. Jemima?
Good morning, teacher.
Yes, good morning.
So I don't know if I got this right, but you say that if one matrix is row, then the other is column. Is that right?
Yes, you multiply a row of the first matrix and a column of the other matrix. A row of this matrix and a column of the other matrix.
No. Okay, like maybe I'm asking if maybe like you interchange it, and maybe like the cost matrix would be in row form, and then like the food stuff matrix will be in column form.
Yeah, like that means you are going to also interchange, because if you put this one in column form, it will be 4. It's going to be what? A 1 by 4. Meaning that also this matrix here you are going to multiply must be a 4 by 3.
Okay.
Such that these ones are compatible.
So it will still get the same answer.
Yes, you get the same answer.
Okay. Thank you.
Okay. So here, according to what people have written in the chat, according to what I've seen in the chat, others you just prove their answer. Here we have 430,000. Here we have what? 4? Is it 96 what? Or 446? You just confirm, then 427,000. So that is what they have. You just confirm. But let me. Yes. Now, Farid Taban, what if I don't use matrix? That means that your strategy is not correct. Because here we are looking at the application. We are looking at the application. Okay. I think people have already got the answer. People have already got the answer. It is 10,000 teacher, not 100,000. Where? 5,000. No, it is 100. It is correct, I think, Cassandra. 5,000 times 20,000 is 100. It is 20, not 2. Oh, oh, Cassandra, look at your work. Look at your work. I think someone may hope to correct. Then after doing so, since the question wanted us to find the total amount spent, then we have not found the total amount. So now what does this mean? Now, here, I want you to know, they may ask you, how much money do they spend on table 1, on table 2, on table 3, like that. In case the question was like that, this amount is what is spent on table A, this is what is spent on table B, and this is what is spent on table 3. So that's, you conclude. Now, they may ask you, among those tables, which table was for the officials for the party? Let me see. Someone, I want someone to raise up the hand and you reason. Imagine that I've told you, among those tables, which table was for the officials? John, are you answering? Can someone raise up the hand? Yes, Sharon.
According to me, the table which was for the officials was table 2.
Why?
Because it has the greatest amount and it has the greatest items on it.
Okay, okay. That is good. Thank you. Simon, for you, what do you have to say?
Like this, table 2. Because it's having the highest amount of that spent.
Okay, yes. So that is how you reason out, eh? That's how you reason out, Chambers. Okay, okay. So that is how you reason out that because this table has the highest amount of money, and you know that for the officials, they always prepare something good, better than the other people. And their things are always a bit expensive compared to other people. Then for you, the ordinary people, that one, it means that your table was for C. And maybe even the question may come whereby they tell you, on those tables, which table was for children? Maybe the children, maybe the officials, and maybe the children, officials, and who? And maybe ordinary people, the elders, they are there. So you need to check out that children, for them, yeah. So you reason out in that format, eh? Yeah, yes. Okay, now after that, please do not forget, I've not written the total. So you come, even show, don't forget to show how you have got your total. You say now that my total is going to be, you add all the money. You show how you are adding for this plus 427,000. Then you come up with the total. According to the chart, people said they were getting this as their total. So that is how you conclude. Then you say that the total, in your conclusion, you say the total amount of money spent. Remember, the total amount of money spent per day is 13 million 30. That is what? 13,003,000. So you remember our question was per day. What we calculated was per day. So here in your conclusion, you will say that the total amount of money spent by the organization per day is how many? I think is 1 million, not 13 million, in fact, because this is, yes, it is 1,303,000. So you conclude like that. Then we are going to okay, okay. Now we are going to continue. That is how we do it. Then we go to the last part. They are telling you that if the company had at most 1.5 million Ugandan shillings to cater for meals, how much more money did they require to buy all the foodstuffs needed for the 2 days? Yes. Let me now check out. Can everyone first try that one and we'll give our thinking in the chat? Yes. Let everyone first try that part. Yes, even someone is saying here, You know, at times these questions can be twisted. In fact, even you may find one time whereby now they have given you where there is a lot of rice and now they put other foodstuffs. You know that now for the table which has a lot of rice, that is for the children and the rest of that. So you keep on thinking, you keep on thinking. So can we first try this one? If the company had at most 1.5 million. So remember we said when multiply daily by 2 days. Very good. Go for a loan. Okay. Yes. Yeah. Now that is the first thing now. The first thing we are going to establish is how much money does the company spend in those 2 days? Remember, now you say money spent in the 2 days because the money we have the money we are having is for 1 day. Are you getting it? So 1 day expenditure. 1 day expenditure is equal to 1 million. This is 1 day expenditure. Now, what about for 2 days? 2 days. What will be the expenditure? It will be 2 times 1, 30300. So now here you calculate how much is that? This is what? 2606000. Meaning that the company for the 2 days will need 2,660,000. Now you ask yourself, but in their budget, they had at most 1.5 million. It means that the maximum amount they had in their pocket was 1.5 million or something even less than that or equal to that. Now, to obtain the extra amount they need, you say that extra amount needed. Extra amount needed. It's going to be the amount the company is going to use for the 2 days minus what they have. I don't know that you're getting it. Because they told that if the company had at most, we said at most means less than or equal to 1.5 million. Now here your assumption is going to be that now they have 1.5 million because it can be less than or equal to that. Now, meaning that here you will say 1500000. So meaning that the company will need 106000. Now here in your conclusion, yes, people have got the answer. Now, meaning that, now, how are you going to conclude? How are you going to conclude? Yes, can someone give us a good conclusion? You can raise up the hand and you give us a good conclusion. Anyone to give us a conclusion here? How are we going to conclude? Hi, Jemima. Jemima, conclude for us.
Good morning, teacher.
Good morning.
Yes, as my answer is the company will require almost 1,106,000 shillings.
Okay, thank you, Jemima. That is good. Lighton.
According to me, I'll conclude by saying the company needed more 1,106,000 shillings to buy all the food items needed for the 2 days.
Okay, thank you, Lighton. That is good. Nish. Oh, Nish's hand is down. Simon.
The company will need more 1,106,000.
Okay. Fugo, yes, that is correct. So that's how you conclude. Liz.
Good morning, teacher.
Good morning.
I would say the company needs at least more 1,106,000.
Okay. So now, Liz, when you use the word at least, then you avoid the word more.
Okay.
So rephrase it.
I would say the company would use at least 1,106,000 shillings.
Okay, good. Yes. Now that would be one of the best conclusion. Why? Now let me give you a reason why using the word at least or more than. One, our assumption has been that the company had a maximum of 1.5 million. But there are chances that the money they had was less than 1.5 million, because when we say at most 1.5, it means that there are chances the company even might have had 1 million in their pocket. So what does it mean? It means that here in your conclusion, you would say that the company would need at least, so at least meaning that it will cater for, even if they had less than 1.5 million, even if they had 1 million, even if they had 100,000, it would cater for everything. I don't know whether you have understood the word. Because here you are not sure, because they told at most 1.5 million. But when they use the word at most, we said it can be less than or equal to 1.5 million. Meaning it can be even 1 million. It can be even 500,000. Even it can be 100,000. So meaning that when you use the word at least, it means that the company, any amount they will get more than 1,106,000, it will be able, you'll be in a position to cater for everything that you needed. Hope that is very okay. Okay. Yes. So now here, Marceline, let's not use the word at most more. Here, use the word at least. Yeah, because here the other word was at most, meaning that there are chances that if the company had something, yeah, you would cater for everything. Jemima.
So teacher, them having at most 1.5 million, that means that they have less, right?
They have less than or equal to that.
Okay. So that means they have little money compared to what they can use for the 2 days, right?
Yes.
Is there a way, like maybe in the conclusion you can like advise them on how to get more money, like to cater for everything after?
Yeah, maybe you can even add it there in your own way, but after mentioning that statement. Yeah.
Okay,
But in case there was a question to advise them on what to do, maybe what they would have done, maybe they can, maybe another question would be, what can the company do in order for them to work within their budget? Now, for such, you advise them that maybe let them reduce on the items for the days, let them cut down the number of days instead of it happening for 2 days, let them do this and this. So you advise accordingly to what the practical solution can be.
Thank you, teacher.
Okay, okay. Okay, now that is, we are going to continue. We have another one here. First read through. Yeah, first read through. Elijah, you have a question?
Yes, I thought the 1,200,000 was money for the 2 days.
Which one?
The
1 million.
1,200,000. Yes.
Oh, remember when we are calculating, the question was saying that the organization prepared serving points per day as follows. Did you see that word? Per day.
Teacher, also, there's this person in the group chat. She's named Amal. She's complaining that you're not picking them.
Amal.
Yes.
Okay, Amal, I've seen your hand. Amal, you can ask. I tell you. Yes, Amal.
Yeah, good morning, sir.
Morning.
I I just wanted to give some like answers, but you didn't picking, but it's okay. Now I know how to like. Yeah,
Okay.
it's okay.
Okay, sorry about that. Sorry about that. Okay. Okay. Let me hope people have read through that question. Okay. Now, because we have said that mathematics is always applied. Now, the first thing I want everyone to do for this particular question, can you first summarize your data in a good table? After summarizing your data in a good table, extract for us the matrix. Yeah, that is what everyone is going to first do. Let's first do that. Summarize your data in a good table, extract your matrix. and then we are going to do it together from that point. Still the other number, we have done it was in one of the mock papers. I don't know which mock paper, but it was in one of the mocks. Okay. So summarize your data very well. So when you summarize, it helps you not to make errors. It minimizes on the errors, and it also gives you time to go through again to check that there are no mistakes that are being made. Yes, we are summarizing. We are summarizing everyone. Yes, Jonathan Pro.
Good morning, Master.
Yes, good morning.
My question is,
Mm.
do they ask you to write form a matrix in 3/4, or you just do what?
No, they don't. They don't. It is you now to think.
Okay.
Mm. It is you to think. Okay. Hope now everyone has been able to summarize your data. Yes. Okay. Yes, Emma. Emma. Emma.
Yes, good morning, sir.
Good morning.
Master, my request is just that if you could help in one day and you look at the topic of circle properties, please, sir.
Okay. Noted.
Okay.
Okay. Okay. Hope now people have finished. Now, okay. Okay. Yes. Yes. Now, but let me be responding to Emma. Now, Emma, what you need to have. Okay, maybe I'll get a day. I'll get a day. So I'm going to first summarize here, and I'm going to say a table showing the baking items. I think these are the baking items or the baking ingredients. I think they call them ingredients, or the baking ingredients for the different types of the cakes, for the different types of cakes. Now I'm going to come here and I say, I have my chocolate cake, chocolate. I have the vanilla. I have the red velvet. I have then the lemon. Now I'll come here and I draw my table where I have the cakes. Then after that, I'm going to put here, what are the requirements when they're making cake? That there was flour, there were flour, there was sugar, we had the eggs, and then we had what we call the mixed ingredients. So when they talk about mixed ingredients, those people who are into cakes, I think you can relate. There are some ingredients that they mix, yeah, and it gives you one mixed thing. Yeah, in order for them to take out the something. So we have the mixed ingredients. Now, after doing your simple table like that, after you are summarizing your data, I'll come chocolate cake requires 3 cups of flour. So I'll come here, you put 3. Sugar, 2. Eggs, 4. Mixed, 1. I come to vanilla. Flour, there are 4. Cups of sugar, there are 3. Eggs, there are 3. And mixed ingredients, there are 2. Red velvet, there are 5 cups. Cups of sugar, there are how many? There are 2. Mixed ingredients, it is 1. Now, those people who usually panic, those people who don't summarize, you'll find them putting 1 like that without reading. That here in red velvet, they did not put eggs. Yeah, because maybe they don't want their cake to get spoiled quickly. Then lemon, 2 cups of flour, 2 cups of sugar, 3 eggs, and 1 cup. Now that is your simple table. You have summarized. Then remember now we are going to, because they told you form a matrix, show the quantities required for each item. So here we are interested in the quantities. So then I will come and I write here, matrix showing in the quantities or the quantities of ingredients, the quantities of ingredients required for each cake, Then here up, I can say flour. Here I can say in cups. These are cups. These are cups. These are cups. I can do it like that. Then after that, okay. After that, we are going to extract our matrix now. I'm going to extract my matrix as 3, 2, 4, 1, 4, 3, 3, 2, 5, 2, 0, 1, and then 2, 2, 3, 1. And then that is going to be my matrix. I've extracted it. Hope that is very, very fine. Members, are we still on the same page? Did we get that? Hope we have the same matrix. Check out. Yeah, people are saying yes. Now I'm going to ask, which order of matrix do we need? In case we are to multiply this matrix, which order shall we use? The matrix we are going to form. Okay, now we go to the second part. Now the second part, they wanted us to calculate the total quantity of each ingredient she will need for the event. Now they told that the baker, now I'm going to first summarize the orders, because they gave her an order. The cakes, I'm going to come here and I say, the baker has been asked to bake a total of 10 chocolate, vanilla, velvet, and lemon. So I'm going to say cakes to be baked. Now the cakes to be baked, I'll come and I say, how many are they? What do we have? Now, still I can now do my summary. Now in my summary, I'll come here and I say, I have here, allow me to use C to represent chocolate. I have chocolate. For you, complete chocolate. You have vanilla. You have red velvet. And you have the lemon cake. Now, when you check here, you notice that chocolate is 10. Vanilla is 8. Red is 6. And lemon is 5. Now, what are you going to notice is that when you are multiplying them, you need to multiply the two matrices. So now here, when I'm multiplying the two matrices, you have to, and I say you have 2 options of doing it. But for whatever option you do, you'll yield the same answer. So here I want members, to use any approach of their choice. Yes. So now the first one, when I form my matrix here, I can form a matrix of 10, 8, 6, and 5. So this matrix here is going to be, this matrix has one row, so it's going to be 1 by 4. Hope that is okay. Because we have 1, 2, 3, 4 columns. And then when we are multiplying this matrix, I can multiply it by a 4 matrix. Since the 4 and the 4 are the same here, it means I can multiply those two matrices to find out the quantity needed for each ingredient. Alternatively, someone may come and say, what if for me I do like this? I make this matrix in this form, 10, 8, 6, 5. This matrix is what? 1, 2, 3, 4. So this matrix is rows are 4 by 1. And then I ask myself, which matrix am I going to multiply it with? A 4 by 4, meaning that if I'm to multiply it, I have a 4 by 1. I cannot multiply it by a 4 by 4. So you can't multiply. These two numbers are the same, meaning that I'm going to interchange. So I can say 4 by 4. I multiply it by a 4 by 1. So now these ones can be multiplied. So for whatever way you do it, you get the same answer. So, but for this particular one, I wanted to use something that we have not tried out, such that members can as well have a feel of the other approach when we start with the quantity other than starting with the money. So now here I'm going to come and I say the total quantity of each ingredient, Now, when I do like that, I'm going to come and I say 10, 8, 6, 5. And I have already summarized my matrix as it was 3, 2, 4, 1, 4, 3, 3, 2, 5, 2, 0, 1. And then I added 2, 2, 3, 1. That was my matrix that I have. Now I am going to multiply. These two matrices can be yes, these two matrices can be now multiplied. So I'll multiply a row, I multiply it by a column. So what am I going to have? Now here you're going to notice that your resulting matrix, if we use this one, is going to be a 1 by a 4. So meaning that I need a bigger space. Allow me to remove this. And I write now a bigger space. So I'll have 10 multiplied by 3 plus 8 times 4 plus 6 times 5 plus 5 times 2. Then this is the matrix I'm forming. Then I'm going to go on and I have 10. Let me see whether another color will allow. I'll have 10 times 2 plus 8 times 3 plus 6 times 2 plus 5 times 2. Then allow me to use another color again. Another color we shall have 10. This is one matrix, remember. 10 times 4 plus 8 times 3 plus 6 times 0 plus 5 times 3. Allow me to use another color again. Hope this one will work. Then I'll have 10 times 1 plus 8 times 2 plus 6 times 1 plus 5 times 1. Now, you notice here, what are you going to notice? You are going to notice that if you multiply in this approach, you will have to write a very long line. Now, I'll come here and now I reduce. So this is going to be 30 plus, now like you keep on doing the mathematics, 8 times 4, that is 32, plus 6 times 5, that is 30, plus 10. Then here, the next one, this is 20 plus 8 times 3, which is 24, plus the 12 plus the 10. Then the next one is going to be 40 plus 8 times 3, which is 24, plus 0 plus 15. Then the next one is going to be 10 plus 16 plus 6 plus 5. So when you add 30 plus 32 plus 30 plus 10, you'll end up with 102. So here I'll have 102. Then 20 plus 24 plus 12 plus 10, we end up with 66. Then 40 plus 24 plus 15, you end up with the I don't know, 79. Then 10 plus 16 plus 6 plus 5, you end up with 37. Yeah. So now that those are the quantities needed for each item. But now you have not concluded. So now you are going to come here and make a conclusion and say, remember, when we are arranging them, if you go back, it was flour, sugar, eggs, and mixed. Hope you are not saying, You be very careful. We started with flour, sugar, eggs, and then the mixed because they wanted the quantity for each. How much flour are we going to use? How much sugar are we going to use? How many eggs are we going to use? And and what about for the mixed ingredients? Now, do not confuse it with the other way around, whereby you are going to find and then you multiply. So now here I'll come and now I'm going to say that the quantity needed now this was flour. Then I will say that flour we shall need, since they gave us in cups, we shall need 102 cups. Then I will say the next one was, we started with what? Flour, sugar. Then you say sugar, we shall need 66 cups. Then we shall go to the next one was eggs. Then you say eggs, we shall need 79. Then the next one was mixed ingredients. Then you say for mixed ingredients, we shall need 37 cups. Kindly, let me know in the chat whether we're on the same page. Kindly. Yes, kindly. Now I'm going to take, yes. Yeah, here you don't cram, hey, otherwise things may. Yes, Jackie.
Okay, so I would like to inquire whether if like you are writing and the space is not enough for you, you're allowed to break it and write some part under it.
Yeah, given that the space is not enough, you can break a bit, but try to squeeze as much as you can.
Okay.
Hannes? Hannes?
Teacher, can you use the other method of 4 times 4 and 4 times 1 matrix and help us solve it?
What are you getting your answer? Tell me. Don't you get the same answer? Yes. Though, okay. Hannes, what are you getting?
I'm getting something else.
Yeah. The reason is you must interchange your matrix as well. Because now for you what you are finding, depending on the way we ordered our matrix, you are finding the chocolate cakes you are going to make, the vanilla cakes, the red velvet, and the lemon. Are you getting it? I don't know that she's getting it. Anis, are you getting it or no? Yes, Anis?
I'm getting it.
Because horizontally, like when you do like this, it represents chocolate, vanilla, red velvet, and lemon. Yet we wanted the quantity of flour, sugar, eggs, and mixed. Hope you have got it. Okay. Angel?
So teacher, I just wanted to clarify something about the different formats. If you use a 4x4 and a 4x1 format, you get a different answer.
Yeah,
So
the
I was
reason.
wondering.
Now, the reason is the way we have arranged our thing is that for that one, you are getting the number, like you are finding like the number of chocolate cakes that are going to come out, something like that. Now, if you are to use that approach, then change here. Instead of having 3, 2, 4, 1, then for you have chocolate here, have the chocolate here, have the vanilla here, have the red velvet here, and have the lemon here, such that you have your ingredients as flour, sugar, eggs, and then mixed ingredients. So here I expect to have something like 3, 2, 4, 1. Then here you'll have 4, 3, 3, 2. 5, 201, then 2231, something like that. Then that's when you can go on and use that approach of multiplying this side by what? By 10, 8, 6, and 5. Are you getting
Thank you,
it?
teacher. Yes.
So that's how you must arrange them. Then you'll be able to get the same answer. Yes. Hope
Thank you.
members are getting that. Yeah. So those people who are using this one, who want to use this one, for you, your matrix must be arranged like this. I told you earlier on that the moment you multiply this, interchange the other side as well. Okay. Hope we are okay on that. So the moment you interchange, we should be able to get the same answer. Sekaita, Emma.
Yes, good morning, sir.
Good morning.
Master, I'm requesting if they have given us the order 1 by 4. Right, like for that very example which you have teacher, they have given us 1 by 4 and 4 by 4. Now, when I want to know the order of my answer will be of a matrix, my answer will be, is it true that I get the rows from the first matrix and I get the column?
Yes, that is very true. Very, very true. Like we said from here, if you were around, I told you 1 by 4 and 4 by 4. This one shows you that you multiply. Then what remains here is a row, which is 1. What remains here is a column, which is 4. So your answer will be 1 by 4. So it is very correct, M.
Thank you, sir.
Okay. Okay, I am saying still another hand. HK. 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 Okay. Okay. Now, yes. Now, people who have used the other approach, you should also be able to get the same answer. Maybe, can you allow me to annotate here in this work such that we can as well help those people who have used that approach to show that, to add them more confidence that your answer has to be the same. So for you, you'll have 3, 2, 4, 1. You'll have
I
4,
slept before I
3.
came back, but I came at around 1:40
Oh,
something.
Excuse me, teacher.
yes.
Teacher, I wanted to ask more about how do you know the arrangement of the matrix?
I'm done anyway. Yes.
The quantities. How do you know that
I've
the
been absent for what?
number of cakes are going to be in rows and then the quantities are going to be in columns?
Now, that's where we come with the one. You first read the question. Go through the question. Now, the question wanted the quantities of flour, the quantities of sugar, the quantities of eggs, and the quantities of mixed ingredients. Now, what does it mean? When you look at that, you notice that in order for you to be able to get those quantities, you must multiply flour times each of those ingredients times each of the quantities that ingredient was made for. So that's where I have told that even for these numbers, look out for the other manual way. Now, I want you to take, if this is how you have summarized your work, and this is how you have summarized the work. Now, the moment you find that you have summarized and the quantities they need are in columns already, are you seeing? I told you that the moment you find that what they want is in columns already, then it means that the matrix you are going to multiply with must be horizontally. I don't know that you're getting it. The moment you find that what you want is in vertically like this, then it means that what you have to multiply with is supposed to be horizontally. Are you getting it?
Yes, thank you.
Yes. Yeah. So that is what you base on. Okay, now I wanted to add the other people who are doing. Now, people who are using this approach, who wanted to multiply like this, still also you'll come and do the same. But now for you have changed. Here you have your flour. Here you are going to have your sugar. Here you are going to have your eggs. Here you are going to have what? Mixed ingredients. So when you multiply, you'll have 3 times 10 plus 4 times 8 plus 5 times 6 plus 2 times 5. I'm doing just the first one. So this gives you 30 plus 4 times 8, which will give you 32 plus 5 times 6. 5 times 6 is 30. Then plus 2 times 5, which is 10. So 30 plus 32 plus 30 plus 10 will give you 102. So that is for flour, which is the same thing we have here for flour. Yes, so that's how you arrange them for people who are doing it like that. So in case this is your flour, you have arranged them horizontally. So that means that what you multiply with will come vertically. Okay, I hope that is very fine. It was a good number that required us to think. Otherwise, you'd end up getting wrong answers. Okay, I don't know why these ones are not going. I don't know what I used. Okay. Okay, hope that is okay. Are we on the same page? Are we good to continue? Members, let me know, and then we continue. You can use the chat and say now we're on the same page, you can move on. Even people who use the other approach. Yeah, you let me know in the chat and then we continue. Yeah, we're on the same page. Oh. Okay, I think people are on the same page, we can move on. So now that is how you had to do. Now the other part, wait, there's a pattern. Oh, no, it is not. Then there was a part. Did I miss that part? Oh, okay, we go back to the part. Now, part number 3. Now, part 3 was saying us, if each kilogram was for that, now they're asking us to go on and determine what would be the cost. They're asking if each kilogram of flour goes for 8,000, each kilogram of sugar goes for 5,000, and each egg goes for 300, and a cup of mixed ingredients goes for 6,000. Find out how much you will spend on making the cakes, considering that each cup with the ingredient weighs that. Now, allow me to first save this a bit. It seems I missed, okay. I think I'm safe. Allow me to do a duplication and I place this slide here. But after placing it, allow me to delete this. Yeah. And then allow me to extend this, that this is part C of our question. And then we proceed. Okay. Now we are going to come here and say, now we are going to summarize. Here, you can first make your simple summary again, and then you calculate the way you want. But I can also say expenditure on flour. You can start one by one, no problem. Now you say flour. How much flour did we use? Now they have told that 1 cup contains 250 grams. Then you ask, how many cups did we use for flour? There were 102. Now I'll come here and I say 102 cups have how many grams? So they'll have 102 times 250. So here I'll come and I multiply, I say 102 times 250. 102 times 250, that is 255, yeah? 25500 grams. But according to the money, they gave us in kilograms. So meaning you're going to say in one kilogram, how many grams do we have? We have 1,000 grams. So you ask how many kilograms are in 25500 grams. So this one means you are going to divide. So I'll have this divide by 1,000 and I will end up with 25.5 kilograms. But they told us that 1 kilogram of sugar, flour. Here we are on flour. 1 kilogram of flour, I'll come here and I say 1 kilogram of flour is equal to 8,000. Not so? 1 kilogram. So if we have 25.5, it means I'll come and say 25.5 times 8,000. What am I going to have? I'll come here and I do my mathematics and I'll have shillings 204,000. That will be now my expenditure on the flour. So that is the amount of money I will spend. Okay. Then after that, we are going to go to the next one. You find out what is your expenditure on. Now we can go to sugar. Now, when you go to sugar, you calculate, you do the same. But let me first allow you to calculate for sugar. I want you to calculate for eggs and mixed ingredients. Let me give you 5 minutes to do that. Let's be doing that. Let's be doing that. Let's now first calculate on our own for each of those ones. And then we see. We are calculating everyone. I have showed you the first one. Let's do the next one. Let's do the next one. I'm saying as I'm answering some questions. Yes, Tams.
Good morning, teacher.
Morning.
So, teacher, this question I was just asking was what you are asking us, like, to use matrix also, like we simulate the price matrix and so
Yes.
That's my inquiry.
Yeah, they can. But now when you are going to do that, if you want to go on and use the what? The matrix, just because here there are very many quantities that you needed to change. So you needed to first change all those quantities in order for you to use the matrix.
Yes, teacher.
So you have to first change such that you deal in the quantities that are needed. So it would be a bit more hectic.
Okay, teacher, thank you.
No. So we are trying out everyone. Okay. All people have finished to get. So what you finish is what we calculate. Sugar, that. Okay. Yes. Okay. Yes. Mulumba. Yes. For here, you can use that. The strategy, it is really very good. Yeah. But though at times you need to look at the question and ask yourself, will it bring out the idea in a very quick way? Yes. Yeah. So that is what you need. But mainly for these last parts, because we have already used matrix, here you can use your approach of matrix, but it will be a bit more hectic, but it is very okay. Given that you have to first convert, you have to first convert everything back to kilograms in order for you to be able to calculate. Okay, now I'm going to come. So they have already told us for sugar, 1 cup is equivalent to 250 grams. And how many cups do we have for sugar? We had 22 cups. So I'll say 22 cups. Sorry, we had 66. Will be 66 times the 250. And when you multiply this is 16500. Now, but you know that 1 kilogram has 1000 grams. So meaning that I'll have 16500 divided by the 1000, which will give me 16.5 kilograms. But they told 1 kilogram of sugar was about, 5,000. So I'll have 16.5 times the 5,000, which will give me shillings 82500. Then after, I'm going to go to the eggs. They told you that 1 egg was costing 300 shillings. So how many eggs did we have? We had 79. So 79 eggs. It will be 79 times the 300, which will give us 23700. Then the last one was mixed ingredients. Mixed ingredients. Now, this is where I've seen some of your answers are not correct, because here you need to read. Reading is very key. They told you that a cup of mixed ingredients, goes for 6,000. And this is where Matia, you need to check that whenever you are dealing, when you are using matrix, make sure you are dealing with the same units. Yeah. Here we have mixed units. We have somewhere where we have in kilograms, and this one remained in cups. So that's why when it comes to matrix, we cannot be in position to mix it up. Yeah, that's why I'm not using the matrix approach, because once you reach here, you're going to find out that now you can't mix up. Here you have kilograms and there you have 100 cups. So they told that a cup of mixed ingredient goes for 6,000. So here you say, how many cups do we have? That 1 cup is going in for 6,000. Then how many cups do we have? We had 37 cups. So here will be 37 times 6,000. So here we shall have shillings. This is going to be 222,000. So people who are not very careful when reading, people have gone on to change those cups to kilograms. Yes. So that is where people have gone wrong. So please, you must be very careful not to make that mistake. Then the last part, they have asked you that now, what is the total? They asked you, find how much should you spend on making the cakes. Yes, now on making the cakes, that means they need the total expenditure. So you'll come here and I say now, total expenditure. Expenditure is going to be, so you add everything you have, 204,000 plus 237,000 plus the 222,000 plus 82500. So our total expenditure, it will be shillings. Add quickly and we see what are you getting. What are we getting for our total expenditure? Total expenditure. Niche is saying she's getting 532,200. So then after you conclude and say that the total amount of money needed to, or the total amount of money they are going to spend on the cakes is now here they use UGX. So here I don't expect you to use shillings. Here I expect you to use UGX. When you check very well, you are noticing they are using UGX. So also you stick to UGX, not shillings. So here I'm going to come and I make that correction. Here we are using UGX. So use UGX because that's what they are using. So don't bring in now your shillings here. So you say UGX, UGX, and all those are capital letters. Then you would have completed the question. Okay. Okay. Now the last one, we can do one more and then we call it a day. Now, when you look at this one, you can first read through. Yes, Master Daniela, that is okay. Yes, but I'm saying some people here are not focused. Okay, you can read through first, and then I want you to first summarize it as well. Yes, first summarize it as well, and then we start.
Good morning, teacher. Good morning, teacher. In a case where the question has given me units for like the currency as UGX and I answer in shillings, will I be crossed or it's fine?
I'm saying, sorry, I thought, yeah, I was saying that they can penalize you because those units are different. UGX and shillings, much as it applies to the same amount or it applies to the same country currency, but stick always to the question. In case the question is in shillings, use shillings. In case it is in UGX, use UGX. Yeah, at times it's not good always to change the units being used. Just imagine you have a car. Instead of putting petrol, for you have put diesel. Yeah, so it's more or less like that analogy. So stick to what the units they have used. UGX, they can penalize you. I've used the word they can penalize you. Yes, more so if you find someone who is very strict. Yes, but remember we are looking for excellence mark. We are looking for excellence mark. I don't want you now to start bringing a debate on your paper that, this person has got 100, but is everything fine? Then they will start looking out for some of those minor things. They say, here, she didn't write very well. So always make sure you stick. Okay, so we are going to try out this one as our last number. Also, this one is a mock paper number. Okay, now they are telling us that your aunt who works very far away from home tells you to identify a shop. Tells you to identify a shop that can give you beans, sugar, posho on credit. On credit is like, in Luganda, we call it a banja. Yeah. on credit and she pays for these consumables every after 2 weeks. I think some of you might have noticed this. When you have your relatives who work from very far and maybe you stay alone or with your siblings at home, at times your parents say, please go to auntie's shop and pick the items. When I come back from up country or from work, I will go and pay her. Such a situation. Then they're telling you that she also tells you to not exceed 100,000 for the 2 weeks. On average, after touring the trading center, you decide to pick consumables from the shop that sells a kilogram of beans, like that. So now they have given us our data. And when you look at these situations, are those people who don't buy things at a go. This situation can really happen in our lives. And more so when you are coming in from those humble families whereby you may not have everything at a go and your parents are working from very far and the rest of that. Now, like I've already told you, keep summarizing your work. So I'm going to summarize. Allow me to use this space to summarize. I'm going to just say maybe a table showing the consumables for the 2 weeks. Show the consumables for maybe you can start for week 1 and week 1 and 2. So I'll come here and I say my week 1, Monday and Thursday. So these are people. So this means that you went on Monday, you picked the items, and then you use them up to Wednesday, they got finished, then you went back. So I'll come here and I draw my simple table. In my simple table, I'm going to come and include that I have items, I have sugar, I have my portion, and I have beans. The moment you have these things, life is sorted. Then you come. Sugar, here I've told you can put units, that these are in kilograms, these are kilograms, and these are kilograms. Whenever things are not in the same units, at times it is hard to do them. So Monday, sugar 2, portion 3, beans 2. Then you go to Thursday, portion. Now here, people who panic, this is where they go off. Portion, when you look at portion, was 4. So I come under portion, I put 4. Beans was 3. Under beans, I put 3. Now that means she did not buy sugar because that one kilogram was still available at home. Because in case you are few people at home, you may not be able to use 1 kilogram of sugar in one day. Then we go to week 2. Now still week 2. So that this was week 1. And this was week 2. So now when we come to week 2, still we shall summarize our data very well. Now our data here, we shall have the Monday, we shall have the Tuesday. Then still our items are the same: sugar, portion, and beans. All of these ones are in what? Kilograms, kilograms, kilograms. In case you don't want to put, you say items, and then you say here kilograms. Then you start Monday, sugar is 3. Portion 4, beans 2, then 1 kilogram of sugar. Then I say 1, that is 1. Then here I'll have 2. Then here I'll have 5. Now after that you go back, and now they have told you that how many kilograms? Yes, I don't know whether there is yes, Mike.
Teacher, like learn for Tuesday, I'm seeing here 1 kilogram of sugar and 2 kilograms of beans, not portion. I've brought here beans first.
Okay. I was saying here. Now that is now you need always to analyze beans. Here they are 2 and portion they are 5. Thank you. Yes. So now you need to read very well. Otherwise, you may end up messing up. So after that, okay, now after that, you are going to come and say, I've finished to summarize. Now you are going to come and write your matrices. So I will come and I say, my matrix. Or I can say matrix, or I can say matrix showing, or I can write them. I say matrices showing the consumables are for the 2 weeks, for week 1 and week 2. Week 2. So I'll come and say week 1 consumables, I'll have 232,043. Then I'll go to week 2. Week 2 consumables. I extract 3, 1, 4, 5, 2, 2. Yeah. Then there are no albums. Yes, Daniela.
Yeah, I thought you're supposed to combine the matches, both of them.
Yeah,
For week 1
we
and
are
week 2.
going. Okay, Daniela, we are reaching there.
Okay.
But you stay on. You stay on. Don't go off. Yes. Now, after, like, you first summarize them. We are still summarizing. You show for week 1, you show for week 2. Then now, since they have told us that all together, it means that we are going to add the 2 matrices. So here I'm going to come and I say total consumables. Total consumables. Hope that word exists. So now when they tell us total consumables, you get for week 1. And then I'm going to add it on week 2. So Daniela, are you on?
Yes, I'm on.
Tell us what we are going to add.
2 plus 3.
2 plus 3.
3 plus 1.
3
plus 4.
3 plus 4. 2 plus 2. 0 plus 1. 4 plus 5. 3 plus 2.
Okay. And what is going to be our answer?
5. 7. 4. 1. 9. 5.
5. Okay. Thank you. But now we have not completed the question. But now I want you to take note. When you check very well, I don't know whether people are noticing that the first column is for sugar. So meaning this is our sugar, this is the posho, and these are the beans. Because we started with sugar, posho, and beans. So that's how our matrix is being arranged. So now that means that we are going to come, because they told us how many kilograms of each. So now we are going to find for each. Hope that is okay. Now, I don't know, for each, it means that for sugar, I'm going to come and I say sugar is going to be 5 plus 1, which is equal to 60 kilograms. Members, is that fine? Yes, Mike. Mike? Okay. Michael, did you want to give us the answer for the next one? Okay. That is for sugar. Then you go for posho. The next one was posho. So I'll say posho is going to be 7 plus 9. And what is the answer? Those people, I'm saying some mics are open. Daniela or Mike?
16.
It is?
16.
16 kilograms. Then I go to the next one, which is the beans. And then beans, what is going to be the total?
4 plus 5, which is 9 kilograms.
9 kilograms. Yeah. So that is how I'm going to conclude. So I will conclude that let me say, the total number of kilograms for sugar was 6 kilograms. For posho, 16 kilograms. For beans, 9 kilograms. That's how we conclude. But don't forget that one column is for sugar, another one is for posho, another one for beans. In case they had asked you, they could as well ask you now, but when you look here, they cannot ask you, they may not be able to ask you Monday, Thursday, Monday, Tuesday, because here the days are different. But in case there was a situation whereby this child has to pick on Monday and Thursdays, then they can ask you, what is the total number of, how many kilograms altogether did he pick on Monday? Did he pick on Thursday? Yes, or the total weight of the items. They can even ask, what is the total weight that this child picked on Monday? Now, if at all it is Monday, because every Monday, you are not saying that she went on every Monday, then it means you just add 5 plus 7 plus 4. But since these days are differing Thursday and Tuesday, then that one, they may not ask. Okay, let me hope. I saw Jemima. Jemima, your hand was up. Yes, Jemima. I don't know that it's clear. Jemima?
No, teacher, has no problem.
Oh, okay. 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 Now that is the first part. So that's how, okay. That's how you had to do it, eh? Yeah. Okay. Now we are going to continue to part B. Now part B wanted us to find how much money will you tell your aunt to pay? Yes, because now your aunt has come back from work and now you need to tell her how much the amount of money she's supposed to pay to the shop or to the lady that was supplying you with the items. Now this is where you need to reason. This is where you need to reason very well. Now here I have said we don't need to cram. When you look at our items, oh, what is happening? What's happening? When you look at our, okay. When you look at how we arranged our items, we arranged sugar, posho, and beans. Hope you are not seeing that. You are not seeing we arranged them in form of here we had our sugar, we had our posho, and we had our beans in that format. And you are not seeing that all of them they were going vertically like that, like that. I don't know whether people noticed that, eh? Now you ask yourself, what was the total number? What was the sugar? Sugar altogether, we had 6 kilograms. Posho altogether, we had 16 kilograms. And when it came to the beans, we had 9. Hope you are not seeing that. Then you ask yourself, they have told you that the price at which those items were bought. So you had one, you had sugar. Sugar went in for what? 5500. Then when you look at what's happening? Is my screen on? Okay. Your screen sharing. Okay. Hope my screen is on. Wait. Okay. Is my screen on? You can let me know in the chat.
Yes, it is.
It is, eh? Okay. Now, we have the other item. We have sugar. You look very well. Is it on, Daniela?
Yes, it is.
What are you saying?
I'm seeing the screen that has the question and you're writing. You're going to Posho.
Okay, portion. Now, when you check here, we are noticing that Posho is what? 25. So I'll come here and I write our Posho as 2400. Then I have the beans, which are at 4,000. Now, Daniela, since your mic is open, tell us the matrix. How are we going to multiply them using the matrix? Tell us the arrangement of our matrix.
We are going to, for the cost matrix, it's going to be I think it's going to be a 3 by 1.
For cost, 3 by 1.
Yes.
Like that?
Yes. Then the quantity matrix is going to be the way it is.
The way it is, eh?
1 by 3, yes.
So which one comes first?
I prefer having the cost.
Your quantity, it means you come here and say my quantity is 6, 16, and 9. Then here you have 5500, you'll have 2400, and you'll have for this. Then you're going to ask yourself, can I be able? Now, what is going to happen is that since how much money will you tell your aunt to pay? So here meaning, when you look here, this is a 1 by 3. When you look at this is a 3 by 1, meaning that they are the same. You can multiply them at a go. So they can be multiplied. So now I'm going to just come here and I say 6. I put my matrix 6 times 5500 plus 16 times 2400 plus 9 times 4,000. So you are going to notice that here you'll get your answers. This is 33,000. Like Daniela got it 38,400, then plus 36,000. So here your answer, when you add, you're going to notice that you get 10400 in total. So here you conclude that since they used UGX, here you use UGX 107,400. So here you have got the total directly from your matrix, even without going any further. So for such a case, this would be the best way to do it than the other one, but all of them are correct. All of them are correct. So here you conclude and say that the how much money will you tell your aunt to pay? Then you say that I'll tell my auntie to pay Ugandan shillings 107,400 because that is the total amount I spent in the 2 weeks. Hope that is very, very okay. Let me, yes, come. Jonathan.
Thank you, teacher. I want to ask about the conclusion, like the concluding part. I want to hear how you conclude finally.
Oh, okay. Okay, the last part, eh?
Yes.
Okay, now let's go to the last part. Now, the last part, they ask us, did you fit in the planned expenditure budget proposal by your auntie? Now, we can first have people give us their proposal. Remember, the aunt told the gentleman, don't exceed 100,000. But according to what we have, it seems we have gone beyond. So let us hear what do people have to say. I'm going to, can we start with the, okay, just give me a minute. Let me stop sharing. And now I share again. Okay. Can I have Nish?
Master. Good morning, sir.
Good morning.
Master, I'm asking like on the calculating this matrices, for us, our teacher said that if you break the rule of matrix, even though you get the right answer, your answer will be marked wrong. Now, for the Daniela's approach, she said that we multiply column by row, yet it had to be row by column.
Where?
Now, like the first one which you calculated. Now, if I do like Daniela's approach, will I be marked wrong or correct?
Now, for Daniela, this is what we had. Her matrix was 5500 2400 4 days, not so? And she was multiplying by 6, I think 16 and 9, not so?
Yes.
Now, this matrix has how many rows?
There are 3.
And columns?
1.
And then the second matrix has how many rows?
1.
And columns?
3.
So you ask yourself, is this matrix compatible? Can you be able to multiply it?
Yes.
Nish, are you seeing?
Yes.
So you can multiply it. The only thing here is that for it, here you have 1 row and you have 1 column. 1 row and 1 column. 1 row and 1 column. Are you getting it?
Yes, sir.
So they can be multiplied. Yeah. The only case that she couldn't multiply, if she had arranged it like this, if it was something like this, here, let me say, if she had arranged it like this, are you seeing?
Yes.
If she had written it like this would be wrong, even if she gets the right answer. Now this is what your teacher was telling you.
Okay.
Because here, when you look at the order is 3 by 1. When you look at the order here is 3 by 1. So these ones are not compatible. So you cannot multiply them.
All right.
I want someone now who's concluding. Lighton?
My conclusion is, since we have an extra money than the one my auntie proposed for, like our amount is 107,400, and she only budgeted for 100,000.
So I subtracted 100,000 from 100,000, 7,400. Then I concluded by saying, no, I did not fit in the planned expenditure budget proposal made by my auntie because the amount exceeds by Uganda shillings 4,000.
Okay, very good. Thank you, Lighton. Vincent. Vincent. Oh, Jemima and Tams.
So, teacher, my question is for later. Maybe you can go to her
Okay.
later, give a conclusion.
Okay. Tams. Oh. Okay. I think I'm not getting you well. I'm not getting you well. I'm not getting you well. Yes? Okay. Now, okay. Okay, Tams, your network is really not so good. Then the last one, I've seen someone who has the hand up. Joan?
Yes, teacher. I had a question about matrix multiplication.
Okay,
I
now,
thought
okay.
I thought when we are multiplying matrices, it would be the row by column, like every row multiplies. Okay, one row multiplies every item in each column. So now, okay, back to the first method that we had tried when we put the matrix for the cost first and the matrix for the item second. I thought since it would be like a 3 by 1 multiplied by a 3 by 3, sorry, a 3 by 1 multiplied by a 1 by 3, the answer matrix would end up being a 3 by 3. So there, I'm a bit confused with how we ended up with 107,400 when we just multiplied one. Okay, the way we did it is we multiplied a row by one column. I thought it's supposed to be a row by all the 3 items in each column.
Okay. Okay. 1 by 1, total is 1. Yes, like now, like I think I've told you, or I've already told you that the best approach would have been this, The best approach would have been this. This one I have used when you are multiplying because it was yielding you to the total. Yes, like we have said, like the way, like we have already said, that in matrix, or when we are multiplying the two matrix, always row by column, but always as long as you can multiply them the order, because now the first we had shared something like this. It was this, and then we are multiplying by 6, 16, and 9. Yes, this one I know 1, 2, 3. So it is 3 by 1. Then here we are multiplying by, this is what? 1 by 1, 2, 3. So we expect that our resultant will be a 3 by 3. But now the other elements that bring out the 3 are like the zeros. They're like zeros, So what we have to do now, the best way, like I've told, because here our resultant was, you have to multiply this times this. So our resultant would have been a 3 by 3. So this approach was not the best approach to use. So that's why I recommend that this is the best approach, since it is yielding you to the total, to the exact total, much as you can multiply these matrices. But here the only thing is that you are multiplying one row, this is one row, and you are multiplying it by one column. Yes, but this approach of multiplying, it was really not the best. It was not really the best because you had to multiply a row by a column. a row by the column, a row by the column. In fact, that is the best way even should have multiplied. A row, this one, by a column, a row by the column, a row by the column. So this one was not the best. It's not the best approach to use when you are multiplying. Hope that is fine. Was it who asked? I don't remember who asked. Yeah. So the best approach, this is the best approach of multiplying. Okay. Let me hope that is okay. Now, okay. 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 Okay, I'm just reading through the chat. Okay, now the conclusion. Yes, now under your conclusion, one, when you read the question, they told us that according to the ant, your ant works what does not exceed one. One, in your conclusion, I told you earlier on, we must have come up with a decision and then later on a conclusion. So now I'll expect you to say, one, your goal or the aim was to work within the budget that your auntie gave you. So here we shall have said that no, the person did not fit within the desired goal of 100,000 because the total expenditure or the total amount of money used or spent in the 2 weeks exceeded or was greater than the 100,000 by 7,400. And therefore, it went beyond the expected amount that the auntie had allocated for this gentleman to use within the 2 weeks. Therefore, the goal was not achieved or the aim was not achieved. Yeah. So that point should come out like that. But like I've told you, including the figures, including the figures, let me hope that one is okay. 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 Okay, now I'm just reading through the chat. So that's how you had to conclude. Okay, now I'm going to, let me take you to, and you take a screenshot of this number. You'll try it in your free time. Oh, that number, it is also a mock paper number. You can take a screenshot of that number. You are going to try it in your free time. Yeah. Yes, okay. Allow me now, I can even now. Okay, Jemima, you can ask your question. Jemima?
So, good morning, teacher.
Good morning.
So, I think I'm going to take you back a bit. There was a certain number we did of cakes and all. So, I tried another approach of making the quantity, the one which was what? Column, and then the ingredients, like the other matrix. And it got me very different answers.
Where? Here?
On the cake. Yes, that's when you got. Yes, I got that one because like I tried that method too. But then I tried another method of making the quantity a column matrix.
Like you
Yeah,
made
and
them
then it got me.
3, 2, 4, 1.
Pardon?
You did them like
Yes.
that? 4, 3, 3,
No,
2.
of like 10, 8, 6, 5, and then it was like in a column.
Okay. Did you change it? Like if you even here, did you change this?
Yes, I made it like that.
So you had 3, 4, 5, 2 and this.
Yes.
And you didn't get the same answer.
No.
What did you get? Okay, you multiply this and we see now what you get.
I got like it's in a column matrix, and it's like it's a 4x1. So it's
here.
75.
So do you have this?
Yes.
The way I have them here.
Yes. Yes, I do.
So you multiply the 3 times 10 plus 4 times 8 plus 5 times 6 plus 2 times 5.
4 times 8. It's row by column, not. I've seen. Have you seen? No. Yes, teacher, I've seen.
Okay. Okay.
Okay, thank you, teacher.
Okay. 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 Let me pick one more hand. Nan Swabra.
Good morning, teacher.
Good morning.
I didn't understand that me to the quorum thing. 3 times 1, 1 times 3. What do you mean by that? It's confusing.
Where? On the last number? Oh.
Yes, the last number.
Okay.
Part B.
Okay. Part B. Did you understand how we got this answer here?
Yeah. I didn't understand the quorum things. 3 times 1, 1 times 3.
Okay. Now. Okay. Now, I want, like, did you understand this second one?
Yes.
Now stick to that. Stick to that.
Okay.
Stick to this, because when you look at this one, it is 1 by 3. And I'm
Yes.
multiplying it by 3
Teacher,
by
where does
1.
3 times 1 come from?
Like
That's
when
what.
you look at 6, 16, and 9.
Yes.
This is a 1 by 3. Then I'm
Yes.
multiplying it by the order. It has 1 low and 1, 2, 3. Not so?
Yes.
Then this is 550, 2400, 400. So this is 1, 2, 3. So this
3.
is 3 by
1.
So,
Thank you.
Okay. Okay. Then the last one, terms.
Teacher, like when we are doing these questions from matrices, we usually do the commodities of the numbers. We rarely do the ones the matrix transformations. Could you be having some?
I'm not really getting you. I'm not really getting you well.
Like we usually do commodities like multiplication and addition, but we rarely do the matrix transformations.
Okay. I don't know that someone has got the answer, but the question, really, I've not yet got you well.
Like some question of matrix transformations, the hands of image, like object times matrix equals image.
You are saying?
Like the matrix transformations questions. There are some scenario questions for matrix transformations.
Yes, I've seen some, at least. I've seen they exist.
Teacher, could you send some, because we rarely see them?
I saw them in one of the mocks. I think, I don't know. Let me first stop the recording. Was it in Kamsa?